think there are totally about 17 people over here. So what we'll do is we'll take you in a special batch after the last session for the FSM tour facility. Okay. What we'll also do is we'll assemble outside and then make sure that you all are moving together. Okay. Will that do?
इसमें कुछ नहीं ये तो ब्लूटूथ है इसका इसकी जरूरत नहीं यूज दिस इसकी जरूरत नहीं ये सब चल रहा है हाँ ओके लैपटॉप भी कनेक्ट हो गया
Can I request all the people outside, if you can hear my voice, we are starting the session. Okay, the next session is very interesting. It takes up from the previous session. There were many questions on digital twin. Should we use software? Should we use hardware, etc.? So this new buzz about AI and ML is being addressed in the next session. We are glad to have Professor Sunil Jha. A short introduction about him. Professor Jha has done his PhD from IIT Kanpur. He has also worked in the industry with Tata Motors, and then he moved to IIT Delhi as a faculty in mechanical engineering. Currently, he's a senior professor. He's also a representative of IIT on the board of FSM. And all the technology integration and incubation you will see later in the afternoon is completely designed, monitored, and it's a wonderful case of somebody from a background of mechanical engineering adopting digital. Like a fish takes to water, I could say that Dr. Jha has taken digitalization as a very natural technology, and that should inspire all of us who might be scared of taking that next leap forward in our careers. Dr. Jha has been a master trainer for all our courses, and he is also an expert faculty nominated on various government bodies, and he advises many other colleges how to enter into the arena of smart manufacturing. Without further ado, I would request Dr. Jha on the dais to take this session on AI and ML applications. Thank you, sir.
Yeah, very good afternoon, and this session is rightly placed after lunch because now human intelligence is no more working. So we need to take a recourse of artificial intelligence, and somehow it was planned earlier and we are running late. So certainly I would like to crisp the session short and would like to have more interaction, because I know that all of you are very much familiar with these keywords floating around in various sessions. You might have heard about these technologies. And certainly 15, 20 minutes or 30 minutes are not sufficient enough to talk deep about the AI. Fine. So what I'll try to do a little more interactive so that keep you awake, and rather than just pushing slides from my side. So how many of you are familiar with the various technologies of AI till now? You have to, so very few hands. I am really surprised. You might not have done the chat GPT or other things till now? No? Yeah, so this is one type of AI. And what else you know about, other than chat GPT, what else you know about AI? There is also a platform like chat GPT's LLM. Yeah. Correct. Any other or anything you understood related to the smart manufacturing or manufacturing, how AI can help? Any idea on that, how these new technologies are going to help? See, the point we are talking about AI means something where the natural intelligence is almost finding a limitation. So where you see your limitations and you look forward that AI will help you in manufacturing specifically.
Increasing productivity, downtime and reducing downtime.
You think human can't do that?
Can be done, but analysis will be.
Yeah. So getting an insight, we see many times whenever you have, and I think in the morning session I was keep hearing there is a large amount of data and it's very difficult to go deep into the data and looking into those tables, graphs. Sometimes it's very challenging for a human mind to understand. So there's a very common concept of a cognitive load. Whenever you look at something and then you have to make an inference out of that information, and then you see a limitation because your mind get occupied in analyzing that information timely and then take a decision actually. And certainly when it's even a small slide with lot of text or the graphs, it's very difficult to depict and come out to the actionable intelligence. What to take after that? What a decision to take after that? You were telling something about the application of AI.
Application of AI in the sense of the visual inspection, so that we can teach the inspection system.
Correct.
Kind of defect. And
Correct.
it can look after that defect in the entire.
Yes. So see, wherever we see there is a vision involved, and human also have a very excellent vision, but the limitation lies then when you do the repetitive task again and again, it's very quite probable that you may lose some defects and it's difficult to detect them. And then this kind of systems basically which can be trained. So there is no one model available as it is there you can program and your system will take care of that. No, it has to learn, evolve from the more and more data and then understand and increase the learning part. So what I'll do, I'll just quickly take you through basic understanding about AI, considering the limitation of the time. I already set a timer of 20 minutes now. So we all understand this revolution we are talking about, Industry 4, is all about AI and machine learning. Machine learning is a small component of the AI implementation. Certainly then there's another segment of the deep learning, and then today we are talking about the large language models and other implementations. So we look forward for actionable intelligence. See, from the data is there, you can visualize it, you can represent the information in the data, but how quickly you can make a sense out of it and take a decision, and that could be an action. So that's a very important part here, how you can derive that. And then most importantly, we would like to train these models or the computers basically on the data. So we will not be very clearly telling the computer this is the way to solve a problem. We are only saying these are all information. Please figure it out and give me the actionable intelligence. So that's a way that we look forward. That's how it's making a big revolution these days. Right? This is one of the statistics I always keep sharing this. This is how it has been projected that in next 5-10 years, which are the technologies which are going to shape the manufacturing. And certainly this list carry a lot about the predictive maintenance, visualization, automation, and mostly the digital twin thing. So I think in the morning session also we were listening about the digital twin. So this is just to give an idea that, yeah, certainly these are the technologies we all have to learn in some way so that we can understand how we can improve the manufacturing part. Most important is the data part, because that's how we are always lacking, because this is something a food for a model. Whenever you are giving a good food to the model, then it's only producing a good results. So very important to understand the data part actually. What all data? It doesn't mean that whatever is coming from the machine is all useful and put into the model and it will predict something. So this is a important understanding. First of all machine learning is probabilistic. You can't be 100% sure about any outcome. So now it's very challenging when you talk about quality, when you talk about any prediction. So we have to be a little careful on the other side, which is not rightly predicted, how impact it is going to make. So this kind of an impression we have in mind that AI, machine learning, deep learning will solve all kind of problems. You deploy something and it will do the job for you. No, it's not right. Wherever we have a very clear analytical, mathematical or deterministic model, don't use AI at all. Please take this as a word from me, because this is how the system works. So we need to be very careful what questions do we want the machine learning model to answer. What kind of questions you are asking the model to answer. Fine. So this is a way, and then accordingly then you will collect the data, and all other integration, the data acquisition, all depend on that. So another thing, you may be having a question in your mind and none of your data is basically correlated with that. That's also quite possible. So is it possible to answer whatever question you want to ask the system using that data, whatever you have, right? So understanding of a data, relation between that data and the response that you are going to predict, how it is possible, whether it is possible or not. This is all the basic learning. I'm just giving you an insight on the pitfalls actually. Whenever we start implementing, deploying, and later we are not able to get the right results out of the deployment of the machine learning models. So this is just one slide, an example I normally discuss. For example, I would like to do a predictive maintenance implementation of one machine. How can I identify which all data is important, which all sensor is important, what exactly I'm going to predict on that machine? This kind of a common sense has to be built up. So human intelligence cannot be ignored before you directly jump onto the artificial intelligence. It has to work together. That's a very important start. So first of all, we need to first find out from the statistics or the experience or the data you have, what type of failures are happening on this machine. Then from which failure to predict. There are many failures. There are many type of failures are happening on this machine, but which one you would like to predict, which is very critical, not able to identify it by normal understanding or human intelligence. Then you need to also understand, is this kind of a failure suddenly happening? It's in a gradual degradation, or there is other way that it's a slowly decline the performance or something. So you need to understand that aspect as well. Then you have to narrow down onto I'm just going to the point which sensor has to be deployed and what specification it should have, so that you will get the right data to predict something. Then you should basically identify which component of a machine is associated with this failure, which you are trying to predict. So then you come to the point which parameter to measure. And finally, then what accuracy and the frequency of the measurement is there. So this is the way you have to narrow down onto the data, which data is relevant. So data collection is very important. Unless you have a domain understanding, unless you have understanding about the machine tool process, it's very difficult to put any data scientist to do a job for you. So that's how we always insist that data scientist is certainly required. Calculator and computers are required, but then human intelligence is also required. So your experience is very much valuable in applying or deploying any of the machine learning models. These are the very common use cases we all are aware of. So there are very standard models are available, known to all of us, those who are little bit connected with this domain. So we have a regression models, we have a classification models, we have an anomaly prediction models. These are the very common supervised learning, unsupervised learning. So then you have a regression and a classification. These are very common technique. Anybody who started the journey in machine learning, they all are knowing about this. Now for a predictive maintenance use case, which model is going to give you what? So some basic understanding is required. Then certainly for deploying this or developing a model, you can use any of your engineer or someone who is familiar with these techniques. It's a simple Python programming, or you can do in MATLAB, or there are many ready interfaces and tools are available these days. So my suggestion to this fraternity is that let's not go too much deep into the nuts and bolts of the algorithms or the machine learning mathematics. Let's try to extract which is useful for you, how quickly you can deploy those models. That's a very important part. Leave those stuff for the computer science engineers to do the research on those domains, because that's how we can progress further. So these are the three different things. Certainly you can predict the remaining useful life, you can predict the type of failure, how it is happening, and many times which you have not anticipated, it can at least detect the anomaly and give you an indication that something is going wrong. We have done some of the deployment in our lab also. So another aspect, so one is the machine side, that is the health, and the maintenance side. Another is on the quality side. So this is a very interesting use case, and I'll recommend that at least all people who are doing machining should use this. This is something which you can predict and to a very precise estimate of the roughness of a component while the machining is going on. You need not to take out a part to take to the metrology and do the measurement of the roughness, no. Otherwise it's too late, you have already produced it, then the quality has gone. So how you can use predictive quality analytics for predicting something which is going on right now, so that you can take a corrective action while the part is in machining or in production itself. So this is something we have experimented, and we get very encouraging results with the very minimal sensors, and that will be really useful in this case. So there are many reasons why there are variations in machining. So we all moving toward the smart machining. And certainly would like to optimize the parameters while the machining is going on, fine, whether it's in a CNC machine or whether it's a conventional machine. These are some of the use cases we come across. So some of the information we got from the literature, but then there are a lot of implementation done on these machining processes, turning, milling, how you can use those outcomes from these algorithms to optimize the process. Certainly once you optimize, you reduce the cost and energy, everything. I'll just give you an insight on this. So these are the various purpose for which the machine learning has been used in the machining itself. So tool wear monitoring, tool wear breakage detections, tool wear predictions, energy consumption predictions, tool wear and remaining useful life. It's very important for the tool so for machinists, it's very important to know the actual state of the tool right now and how you can do that. So that's a way. And then what all parameters they have used to predict this. This just to give you a confidence that the kind of accuracy that has been predicted by the people already. So most of them are above 90 or 99, 95. It's fine actually. At least you will get some sense of the current running state of the tool. And then certainly beyond certain level, you have to take an action. And that could be flagged by the model itself. So this is this is one of the implementation we did in our lab itself. So just to experiment ourselves, because whatever we are sharing is through our own learning. So in this case, we have just deployed 2 sensors. One is the vibration monitoring, another is the spindle current, that's all, nothing else. And we will be able to do a very good prediction of the tool wear. And even not only that it's good or bad, we are also predicting the quantification of the tool wear. That can be done in this case. So this is how we have done it. We deployed that, we did the experiments, trained it. These are some of the results basically. So within the 95% confidence interval, we will be able to give an estimate of the tool wear that has already happened on this. And if you have this information beforehand, I think that's the best part in the machining process. So this example is of machining, but certainly equally applicable to other processes as well. This is what we have done on the roughness itself. So without putting any single metrology instrument on the machine, we are able to predict the roughness, and which is almost the predictive and the actual that we have measured later on. They are matching very in close limits. So this is the way you have a continuous monitoring of the roughness of the part that is in the machining. So these kind of applications are really adding a lot of value because you are able to control the quality when it is going to produce. We are now moving into the lathe machine. So we are doing experimentation to do the similar implementation for a very old, you might have seen in the morning sessions how a lathe is being made smart. So smartness is now we are trying to put this machine learning predictions also into that models, so that we can also visualize the similar outcomes in the turning operation as well. So this is how the work is going on. So our efforts are basically collective done by the students, the project staffs, and the learners who are get associated with us. So that's how we are trying out and proving these use cases. Similarly, we are also implementing some of this quality analytics part on the welding cell, so that you may see, some of you may visit our lab after the sessions are over. So our intent is basically welding is another very critical process where the defects are creating a lot of problem. Even a small defect will lead to the whole part rejections. And later you realize when you do NDT, because sometimes you get to see the defects from the surface, sometimes they are volume defects. So how we can use the information that is available? Certainly you can monitor the current waveform, you can monitor the voltage waveform, you can use acoustic signals, you can use some sort of camera to capture the weld pool. Using all this information, how you can predict the quality of the weld. And then while welding is going on, how you can adjust those parameters so that they will not lead to the defects. So that's a way we can save the whole component. So this is one of the work that I think we have around 3-4 PhD students working in this area and few MTech students who are doing. So these are various use cases of the deep learning itself. So real-time weld monitoring and the quality inspection. And this is a way how we will be predicting the quality while it is going on. There are other possible use cases. Certainly people are using machine learning for the design aspect itself. So generative design is one new technology that people are talking about, where those who do the design, how many are the designers over here designing any components? Anyone who designed the components for the machine? And the good thing is that because now you have additive manufacturing also available with you, so whatever you design, it will make for you. So optimization of the design, generating various options for the design. This is one of the technology. You give your inputs. I want to have the weight this much. This is the strength I required, the location where you want to have a strength. The AI will optimize the whole design, and it will generate the design as per the specifications. Many times we may not be able to visualize those aspects of that. So it will produce array of possible designs. And then you can just select one of them and do the further analysis and choose one of those designs. Many times from a human intelligence, we may not be able to visualize those possibilities actually. So AI is just opening up all those possibilities for you. This is one of the use case that we have implemented on the vision itself. We are talking about it's just for the inspection itself. So we use deep learning algorithms over here. See, our learning, how it is helping industry is that, see, the hardware is not that costly. The IP and the learning and the models that you are developing, it will bring down the cost of the computer vision drastically. So using a human resource, those who are aware about these kind of learnings, we normally use students and they use open source models that are available and develop a solution actually. So this is one of the solution developed for industry itself, so how the piston inspection can be automated with the help of robotics and the computer vision technology. So these kind of use cases we keep doing in our lab, and certainly look forward that any one of you have these kind of things can be done very easily with our learning in the last 6-7 years and with the help of the students and the staff that we have in the lab. Certainly this is also very useful for maintenance use case. So this is a complete workflow we have designed for developing an expert maintenance system, because maintenance is another challenging task these days. Reason being, you can't have all the information in your head, and when you are addressing the machines, the number of machines are also very large. The complexity of the machines is also very increasing. So in that sense, how we can do this kind of a workflow implementation, where if you look at this, how the technologies like digital twin and the deep learning, machine learning will help you in analyzing the system behavior and the fault diagnosis. So that's the first part. So before that, you need to represent the information about the machine in a digital form. That is must, because computer can't understand other language. So you have to digitalize all the relevant information related to these subsystems. I just listed out some of the subsystems. They're very common in all the machine tools these days, or systems in the plants or manufacturing. So you have to digitalize this information so that that can be used and processed along with the real-time data coming from IoT. Then we will put these tools of the CPS, digital twin and machine learning to do the fault diagnosis, at least narrow down to the location where the fault is. Believe me, I think those who did the maintenance, anyone from a maintenance fraternity, you know that many times it's very difficult to find out where is the problem actually. I know how to solve it, but locating that problem itself takes a lot of time. And then you need to do the maintenance in such a way that the first time you do it correct actually. Anyone who is even not familiar with that maintenance practices. So we can use later on the technologies like AR to guide people to do the maintenance. So first diagnosing, narrowing down where is the problem, what type of problem it is, what is the solution that is being prescribed, and finally guiding a human to do the repair and finally maintenance. So that way it can reduce the maintenance time significantly. That's the important. The last slide I have is basically how you evaluate the machine learning models. So as I said, it's all probabilistic. I said that this is 85% accurate. Someone will say this is 88% accurate. And I showed you the slide which says 95% accurate. What about the other aspect, which is not being predicted correctly? You have to be very careful and analyze those aspects as well. And this is a scheme which is known as profit-sensitive scoring actually, because all interpretation of the numerical or statistical information from these models has to be done in the business sense. How you will assess which model is good and good enough to give you a benefit out of this implementation. So this profit-sensitive scoring is another way where you have to analyze the outcome or the statistical numbers, whether I say accuracy or the other measures of the model, how it will impact the whole financial aspect. So financial impact is to be analyzed in this case. So because data science is something which is not giving you an estimate. So if I say 88% is rightly predicted, 12% not predicted correctly. Now, what is the implication of these 12%? If that is too much detrimental for the whole process, then don't implement this model. You can further improve. Or sometimes even 78% is good enough for do the prediction. That all assessment should not be just done by the experience. You have to use this approach to assess financially what kind of impact it is going to make it on the system. So this kind of approach we normally train people. So time is not there. Otherwise, I normally take an example and explain. How do we know if it will have a strong positive impact on our business? Whatever model you are suggesting, this has to be gone through. So this approach is very important for all people who deploy this machine learning in the business applications. So that's the last slide from my side. Thank you so much. I finished within the time. Yeah. You can show the example. That example of profits, it will take another 10 minutes, sir. Okay, then I'll just see that I can show you that. let me just dig out that model. Till then, any question, whatever I quickly shared with you, any inputs, I am just trying to find out where is the slide with that model actually. Yeah, please. I'm sure that you made some sense out of the quick explanation of the AI things. Yeah, please.
Your this example on machining systems is very interesting
Mm-hmm.
to me because I come from that same faculty.
Mm-hmm.
I want to know about this business sense. Does
Hmm.
it make to any existing business who is into business of machining parts or something like that? Does it make sense to them to like saving the time of their tool changes and all those things?
Yeah, so certainly, because see, some of the developments, whatever we have done right now, they have been done in the lab actually. And we have established the models are working fine, and then we have proven it actually. This is the proven use case actually. We look forward someone to take this and deploy it actually. That has not been done till now. We look forward some of the visionary over here, they may look forward to deploy these things and then make a sense out of it. It has not been yet deployed actually, yeah, deployed. Mm-hmm. Press shop, no, we have not done yet. Yeah, not done yet. Yeah, because mostly in our workshop we have forming, but we have started from the machining. We are trying to do on the shearing basically. So sheet metal, little bit on the shearing part. We have done some integration, and the welding is the another area.
We'll be happy to learn that.
Sure. Looking forward. Yeah.
You talked about tool use case.
Mm-hmm.
So two things specifically into like one is like the breakages, another is like the one out of the life actually.
Correct.
Standard life.
Correct.
So what exactly the potential benefit you guys have actually realized? So can you just touch upon that?
Yeah, so our benefit is basically because the application that I have shown you is a micro machining process actually. And micro machining process means my milling cutters are of a order of 1 millimeter, 2 millimeter and running at almost a lakh RPM. And when we are going to produce a miniature component actually, so if a little bit tool wear has been detected, it will certainly spoil the whole component actually. That's not going to give me the precision that I'm looking forward. And while the machining is going on, it's very difficult to get an insight. So suppose the machining time is 25 minutes, 30 minutes actually. It's very difficult to check anything in between. If the tool wear has already happened and it start deteriorating the components, that kind of insight is not available. Only after the component has been produced, we will do some inspection either through the microscope or with the measurements. So that's what the intent is basically, to realize the moment we know that this much wear has already happened actually, let's stop the process and change the tool right now. So that kind of benefit we have seen in this implementation. Sometimes it happens that because this is a CNC machine, so we know that this part program is going to take another 25-30 minutes to run, and we realize that the current tool is not sufficient, or the wear has already happened on this tool. With these cutting conditions, it may not sustain another 25 minutes, 30 minutes. So rather than using that tool and intermittently detect there is a problem, you should not use that tool, use another tool actually. So tool selection in the beginning itself also can be streamlined with this understanding. In fact, we are trying to also build a digital twin of a tool cutter. Normally, see, you are talking about the digital twin of a machine, but tool is also very important. You can maintain a complete life statistics of that tool, on which condition it has already spent the life and how much the next step you are going to run on it. And then you can predict everything before you actually realize the failure. You can at least get a sense of that before you attempt it. So those kind of insights can be made through this. Yeah, please.
Maybe it's a question which is irrelevant.
Mm-hmm.
But I just come from Dubai from a conference.
Mm-hmm.
There people are already talking of Industry 5.0 and rather Industry X.0. Now whatever we are doing here, so how fast again this is going to become obsolete?
No. So yeah, it's a very pertinent question and important question. So versioning is not making the previous version obsolete, at least, because we are talking about 4/3 has not been obsolete. Robots are still existing, automation is still existing, CNC machines are still existing. It's only the upgradation, additional part what you are going to add on top of that actually. So it's not that the next version comes and the previous version get obsolete, first of all. Whenever we are talking about 5, certainly there are certain aspects we are going to address more deeply. This is not going to go away. it's certainly going to contribute towards that only. So if we are talking about sustainability, we are talking about more people-centric approach. These are all additional things that we can do over Industry 4.0. So certain attention which we have not paid earlier, now we are more concerned on them, and we are trying to deploy technology to address those things. So that's a quick response on that. Thank you. Any other? Sorry, sir, I cannot come out with that. I'll take some times later. Yeah. So, yeah. So I'll request the another speaker. Yeah. Sure.
We'll request Dr. Jha to stay here, and I'll request our next panelist, Mr. Nilesh Lakhane from Maruti Suzuki. Nilesh has been, please come on the stage. Nilesh has been working in the maintenance department of Maruti Gurgaon for almost 2 decades. He's had experience in maintenance of machines and also maintenance of electronic equipment. So he will highlight some of the user problems, user challenges, and user experience. And then we will continue this chat with question answers, and you can feel free to ask the relevant speaker your questions. So Nilesh, would you like to start with, can we have the mic? Yeah. You can sit there and share your experience.
Hello everyone. Am I audible? Okay, myself Nilesh Lakhane, working as a manager in the Maruti Suzuki Gurgaon plant. So basically I am working in the maintenance department. So for the Industry 4.0, the AI, the artificial intelligence, it is a new age technology. It is creating the new trends in the manufacturing. Specifically in the maintenance field, the predictive maintenance by using the AI, it is the need of the hour. Okay, so in maintenance, the predictive maintenance is basically the predicting the life of the elements and taking the corrective actions well in the advance to reduce the breakdowns and to increase the machine availability and to increase the machine reliability also. And it helps us in effective use of our resources also. So to start with the Industry 4.0, we have implemented some basic ideas by using the IO-Link sensors. So we use the IO-Link sensor where the setting of the sensor is much difficult, and it is the safety issues also. So by using the IO-Link sensors, we displayed that distance to the HMI. Okay, and by seeing that distance, we can set the sensors accurately and with no any difficulties. So that is our first project. Also, by using the IO-Link sensors, we displayed the analog graphs of the fluid, like the cutting coolants or hydraulics levels, pressures on the screens. Okay. In the next phase, we have connected some machines to the central servers and take the data such as the fault histories, warnings, predictive features, diagnostic parameters, some cycle time, like that data we have taken onto the central servers. By using that data, the concept persons can monitor that data at their own locations and plan the maintenance activities well in the advance by seeing. Suppose, for example, if there is any alarms regarding the insulation fail of the motors, warning, not alarm, it's a warning. So the maintenance persons can plan the motor renewals well in the advance by seeing that data centrally. So that is one of the advantage of this connecting the machines to the central servers. Also, we can we have a lot of the current trends and temperature trends available on the central servers. So we can monitor that data and take the actions accordingly depending on that graphs. But we have to do it manually. And artificial intelligence will play the major roles to do it by machines or it automatically. And where we look for the artificial intelligence. So we have some identified some cases where we are planning to use the artificial intelligence for our benefits. The first case is the TBM. TBM is a time-based maintenance. That is the one of the concept in the maintenance. So in time-based maintenance, we generally, we have to replace the machine elements according to their life. And the life, the mention in the catalogs is in terms of the hours, or for suppose for the contactor in terms of the on-off frequencies, or how much multiple times it will on or off. Okay, so now we don't have that features on the machines to calculate or measure the life of the elements. So we replace the elements just after 5 years or 10 years like that. So we can't use the resources effectively, or element life effectively. Sometimes it will get underutilized, sometimes it will get overutilized also. So now we have the data, we have all the signals on our central servers. So by using that data, we are planning to we are planning to develop some algorithm or program so that we can measure the life of that elements and replace that elements according to their life. Okay, so that is one of the case that we are trying to develop. The second case is now in machines. I will give one example. In CNC machines, there are 3 to 4 axes. For each axis, there is a servo motor, ball screw, and bearings all are there. And motor current data available on the server. Okay. So by that current data, how can we identify where is the abnormality? Whether it is in motor, whether it is in ball screw, whether it is in bearings, or whether it is at load side, machine load, like cutting tool is blunt, or something cutting load is there, abnormal cutting load is there. So how to identify that? That is one of the challenge in front of us. So we explore the solutions, but we found one solutions like that. Some conditions are the dynamic, like when the tool gets blunt, we don't know, or when some cutting load will be there, we don't know exactly. So that's why we move the axis without any load, free load, and take the signature graph of the current. Okay, and by seeing that graph, whenever we want to do the analysis of that current, we have to run the machines in that specific zone, take the graph, and match that graph with the signatures. And then accordingly, we can identify the abnormality in our motor, ball screw, or like that. So here we have to exclude some dynamic conditions, like load, cutting load, or like that. So we have to, again in that case also, we have 3 elements: motor, ball screw, and bearings also. So now we are looking for the solutions where we can narrow down this analysis to the fixed elements. So where we can get the decisions that the motor is faulty or ball screw is faulty or like that. So we are looking for these solutions also. That's it. Thank you.
So I think whatever I was just explaining to you, just give you a real insight. Certainly everyone is working towards as narrowing down where is the problem. So maintenance use cases from the current waveforms or the other sensor information you will be getting. I think these are the practical application of this machine learning. Especially there are many applications of the machine learning and the AI, but this fraternity, I assume they are working towards the manufacturing, how we can improve the manufacturing by use of these technologies. So I think these are all from our side actually. We look forward any other query that you have, and then we can address on that aspect. Yeah. Any questions from your side? Yeah.
If no one else, then.
Yeah, please.
Usually we use the viable distribution in the case of failures in the bathtub curve. Now, usually in maintenance failures, the viable distribution is used, the bathtub curve. And in your case, when for the machines running or the tools, is there some other distribution or also viable distribution is applicable there? Have I made myself clear? What I'm saying is there some other distribution or again the same viable distribution for the bathtub curve failure type of thing? You're aware of the bathtub curve?
Yes, sir.
So what I'm saying is that also extended in your case?
No, sir. Now we are just looking for some signature analysis, current signature analysis. We are taking some signature of the currents. So as there are some dynamic conditions are there, so we can't analyze that conditions now. So in certain zone that we have to take the graph and we have to analyze the graph according to.
Thank you. I'll get back to you.
Hello, sir. Hello, sir. I have one query and one suggestion regarding the last point that you said. You are not aware like whether in a motor is the problem or the bearing is the problem. So I think that is where the digital tune of the whole model comes into picture. So you connect a Hall sensor. Most probably you are discussing about that, the current sensor that you are telling. So you take a data from the current sensor and feed in the digital model, so that whatever the effect that is coming out from the current sensor, that same can be replicated in the digital model. So with the usage of one or two sensors, we can actually replicate the whole system. So that is one of the way we are looking forward of digital tune. And second, one query is there. I got an opportunity to work for multi-spindle head, one of the uses of one of the machine that is being used in most of the industry in Maruti also. So there were 27 bearings were there, and I think 13 to 12 gear are there, spindle gears are there. And the problem of that time, I'm talking about 4 years back, the problem of that time was whenever there is a defect is there, you are able to identify it, but for that defect you have to change the normal custom rule was there to change all the bearings, 27 bearings and all the gear set, and that takes the half of the day of the work. So how do you now, because it's being a 4 years, so how do you now encounter those issues? Because acceleration, we have tested that in our lab, and we have put the whole machine in ICU. ICU means we have kept 9 sensors, tacho sensors, and all those we have kept. But I don't think that is a practical solution for those kind of, because in regular time you cannot put 9 sensors all the time. So how Maruti is looking forward for that kind of issues?
Now there is no that much progress. We are looking just some solutions for that cases also. But you are suggesting to put some sensors on the machines. But Maruti have a lot of machines, and in one machines there are 2-3 axes. So on each axis to put the separate 2 or 3 sensor is not viable solutions for that. And we have to implement it on the multiple machines also. So we are looking for the solutions based on the data available with us. So we have the servo motors on the machines mostly, servo motors, servo drives. So some diagnostic features are also there on that drives and machines. So with the help of that diagnostic features and that data, we are looking for the solutions.
Thank you, sir.
I just want to add one thing here, because the digital twin will help you in putting a lot of virtual sensors. Whenever you physically model the whole system and getting a real-time information from the machine tool, so you may be optimizing the number of sensors required. So initially you may have a 9 sensor or 10 sensors. Later, once you have a physics model which is being proven with the real-time data, you can deploy as many virtual sensors to give you a better insight actually. So that's another way you can improve with a limited number of sensors, but you have a better insight into that.
Yes, sir. Thank you, sir.
Okay, sir, I think we are done. There's no more questions right now. Yeah. Thank you. Thank you.
Urvi, can you step out? So it's a very fascinating to know that maintenance, which usually we think would be a very boring department, can come up with something so interesting that Dr. Jha has to look at solutions using AI and ML. Big round of applause once again for the 2 speakers.
So, good afternoon, everyone. I'm back again from the cloud to the ground. So, we now proceed to our fourth session, which is on process maturity and database decision making. And the speakers are Mr. Anirudh Kadkol, Mr. Kalyan Ram, Mr. Sandeep Dongre, and Mr. Laksh Malhotra. And I would now like to invite Mr. Kalyan Rambi, who is the CEO, Indexo AI Private Limited, empowering manufacturing organizations to achieve excellence in operations and redefine their business landscape through the power of AI. Kalyan provides strategy and insights, drives innovations, defines organizations' business goals, and ensures business development. Kalyan also heads engineering design team that includes designing solutions to Industry 4.0 for manufacturing and remote laboratory of academic institutions, control system, design solutions for defense and aerospace, industrial automation solutions, software, hardware, system in loop simulations, IoT for engineering applications, and research infrastructure management solutions. Kalyan Rambi is also the president of International Association of Online Engineering, Austria. Welcome, Mr. Kalyan Ram, sir. Over to you. Pointer for the use. Thanks.
Thank you. Okay, great. Good afternoon, everybody. Firstly, I would like to thank AIA, Anup Badwaji, and the team for facilitating this wonderful event. And I would like to run through some of the factors that are defining decision making using data. So how we understand that this entire aspect is on process optimizations and also facilitating decision making, how we can actually take decisions based on data, for which I think one of the steps is what is data. So before I get into all this, I would just run through quickly on what we do so that you get an idea of what we do. We, as an Indexo AI as a company, is erstwhile Electronic Solutions. We've been there for over 13 years, working on technology solutions in digital transformations. What we are focused with the recent transformation within our own organization is to focus on the elements of AI. We have been working on generating data, data source management, getting data into the system, then translating into dashboards. Now it is time to kind of get into the insights of data. When we talk about AI, the whole idea is what are the insights? What can we do with the kind of data that's available? There were a bunch of questions that were already asked. I think I'll try to touch upon several of them as we go along the way. So that being our focus, how do you first define the data source? How do you generate the data? How do you consume the data? How do you store the data? How do you process the data? And then how do you visualize the data? And then further, how do you create insights out of the data? For all of this, how does the data look like? I think we'll also touch upon some of those aspects. We understand that Industry 4.0 means many things to many. I understand it starts with the IIoT platform because that's where the data is generated. IIoT platform includes what is the source? How does the data come? Where does it come from? So you heard a lot of this earlier during the day, the sensors, the CNCs and PLCs themselves being data sources. And if there are no CNCs and PLCs which can facilitate data, then how do you try to get the data? There are a lot of aspects that we had gone through in this aspect. Once you start generating data, like in one of the previous discussions, it was also said that 7 machines, you get the data, you can deal with it. What do you do with 70 machines? The next question is 700 machines, 7,000 machines. It can go on. So that becomes the biggest piece. How do you analyze data? The big data analysis becomes the next big piece. That's the next big challenge. Of course, autonomous robotics, a lot of feature management systems, all of that has also been discussed. I'm not going to touch upon all of them. Very soon, we will notice that security becomes a problem. Today, we understand that the industrial data spaces are known to very few people. I mean, when I say few, it is in comparison to the other hacking world, say financial data, for example, right? You know what kind of hacking environment exists. But you don't have that kind of a hacking environment yet on the industrial spaces, primarily because there are only a handful of people who know how to deal with this data or how does this data work, how to access the system and all of that. But very soon this is going to change, because where there is money, there is always good and bad. So you will start seeing people coming in these spaces also, because there's a huge amount of money in the manufacturing space. It is less understood, but it is going to be humongous, unbelievably humongous. What is estimated as such is what the financial world, you know how this digitization came into existence in the financial world, that is going to replicate in the manufacturing world, right? That's the story. We all know how you were originally writing checks to draw cash, and today, forget about check. You don't even draw cash, right? So the whole objective is lost. The idea of writing a check was to draw cash, right? Or transfer cash. So you don't even draw cash these days. It's just out of the picture. So that is what is going to happen in manufacturing, for sure. There's no doubt. Whether we like it or not, it's happening. Now, then that is when the security becomes critical. Cloud, he just came back from cloud. How was it? Good? So cloud, what happens is, it's basically centralization of data. What we are trying to say as cloud is basically you're putting everything together. Imagine few years ago, you know how you were dealing in terms of difficulty with transferring files from one computer to another, one device to another. How difficult it was. You have to put a pen drive, or earlier you were using floppy drives, then it became pen drives, and you were doing something else. And then you said, now, why do I need to transfer the file? You don't need to transfer the file. Just put it in one place, everybody can access it. That's the easiest way to deal, right? So, you are all from manufacturing, you know the principles of lean, right? Fundamental principle of lean, one of the important principles of lean. Quickly, anybody? Okay. One of the important thing, single piece law. One of the important things. Movement is a waste. Any sort of movement. Out of the 7 wastes, movement is a waste. Defined, very clearly defined. So data movement is also waste, right? Why should you move data? That was the principle of cloud. Why cloud came into existence? Because movement of data was a waste. Why should I move the same data 100 times? So much of waste. Very soon you'll realize computers are becoming more powerful, systems are becoming more powerful, and your consumption is also becoming more powerful. So every time you think that it is just another 10 KB of data, it's not just 10 KB of data anymore, because the consumption is so high that the 10 KB of data, when it actually exponentially consumed, becomes very, very high. So fundamentally, if you're moving data in your organization from one database to another, from one source to another, believe me, from principles of lean, it's a waste. It's a very big waste. Your servers and systems will never be sufficient, irrespective of what you do. So it's extremely important not to move data. And you need to figure out how to do that. So that's the crux of cloud. How do you ensure you don't move data as much? Of course, one movement might be needed. Whatever is necessary is necessary. I'm not saying that. You might have to deal with some problems. I can give you hundreds of examples on that as well. Augmented reality and wearables, we just discussed some of the very interesting points that, you want to communicate information between two individuals in a smartest way. I think that's what is coming up very soon. That's going to be very interesting over a period of time. It might sound a fancy thing right now. Gaming people might be super excited with all of that, and you would be enjoying it. But trust me, that's really, really going to be a huge business translating into real value over a period of time. Additive manufacturing is spoken n number of times. It moved from original plastics, different types of plastics. Now we have metal also in a very big way. So that is definitely going to take the shape it has to. Digital twin, we heard hundreds of times. I think there was 4 or 5 questions straight in terms of digital twin. Digital twin, again, while I touch upon it, there's a whole lot of things around it. Digital twin itself is classified in multiple types. You have digital twin as in a software digital twin, as in a virtual environment. You have a phygital twin, a physical digital twin. You have a digital twin. So you've got multiple digital twins. So when you talk about digital twin, I think we should really, really think upon ourselves as to what exactly are we expecting? What is our objective behind it? What are we trying to do? So keeping all this in mind, again, my objective being focusing on data, I will run through it. What are the typical challenges in manufacturing? I think you're all here. I would like you to tell your challenges. We have just captured a few. Okay, definitely unplanned downtime. That's becoming very soon. That's becoming the big thing, because most manufacturing evolution in India happened from the mid 80s. We all know how it started with the automotive industry really getting up. And today we are at a stage where a lot of stabilization has happened at the production layers, more or less. I mean, it's all great efforts from all your predecessors and yourselves. It has already come to a pretty good extent. You compare this with slightly developed economies, like how Indian evolution of manufacturing has happened. In terms of developed economies, precisely, India is highly influenced by Japanese, you know that. Every manufacturing entity in India has an underlying Japanese base, right? We all know that. So keeping that, you look back at the Japanese evolution, you look back at the European evolution and the American evolution. America anyway outsourced everything later to China. But anyways, just look at the evolution. You will notice this one thing very clearly. In the evolutionary process, first focus will be on production. Production will be the burning issue, right? Immediately after production, once your production is stabilized, quality will be the burning issue. Okay? Once production and quality is reasonably stabilized, then people will wake up for maintenance, saying that, okay, now maintenance becomes important. Otherwise, maintenance is a thankless job. It is there, right? So this is an evolution. Don't be too good, sad or happy about it, but it is how it is. We all know it. So that is where availability, unplanned downtime, and all of this comes into picture. We understand what are the challenges around that. And then coming to the second element of skilling, training, I'm not specifically talking about production and quality intentionally, because that is given. That is definitely given. And a majority of Indian manufacturing entities, even at the small and medium enterprise level, have decent levels of, production definitions. I'm not saying productivity. I'm saying production. Production, they're okay. They're coming somewhere close. So a lot of benefits are there in digital. I don't want to show this slide. Of course, I can always tell you 30%, 40% and all of that. We'll get there. I'll show you actual data, and that will be more interesting. Assessment of decision, at each stage becomes very important. So assessment of decision at all of these stages becomes very important. So now we are going to talk about what is the decision and how the decision is based on today's, how you're doing it as is basis, how are you doing it today, and how you might be able to do with data. So I'm going to try and see how I can show you some data. Typical parameters of focus, I think we have heard earlier during the day also. OEE, overall equipment effectiveness. Energy, we have heard a lot about energy. To life management, very soon this is already a headache in most organizations. Very soon it's going to become a bigger headache. It's as simple as that, right? Basically, check sheet digitization, we're going to have another wonderful talk after this in this same thing, so I'm not going to touch much upon that. We have an expert sitting here for that. Inventory analysis, workflow analysis, takt time analysis, blah, blah. Maintenance, MTTR, MTBF, alarm analysis, root cause analysis. I'm going to take a case study on this as well for you. Servo spindle load, we heard a lot about Dr. Jha also mentioning very specifically on this in terms of what you're going to do with servo and spindle loads and speeds and all of that. We'll look at that. Battery management as well. Quality, CPCPKs, PPPPKs. I'm going to show you precisely how CPCPK will look on data in front of your eyes when you look at it as a screen for every single parameter. We'll have a detailed analysis on top of this quickly. And safety skill, we have spoken about safety elaborately last time in the previous session. I'm not going to dwell deeper into that, but focus will be on these things. So this is what we do as an organization, end-to-end, shop floor to top floor, and some of the architectural elements. I'm going to rush through some slides, bear with me on that. This is one case in point. I think most of you will be able to relate, but people who are already there, who have spoken so much about servo and spindle maintenance, can you kind of identify what's going on here? It's a very raw data slide. This is not the original data slide. This is just a representative one. But can you quickly see what's going on here? This has happened. We were able to identify this only because we had a data. And I'll give you the context of this. This is a high-speed through coolant spindle machine. 18,000 RPM through coolant, which means the coolant flows through the spindle. There were some random accidents on this machine. It's a 100% imported Japanese machine. 100% imported, not old. It's hardly less than a year old. 100% imported Japanese machine. Random accidents. Most of the time, operator being blamed. You might have done something because of it happened. And the accident was really disastrous because, through coolant spindle machines, the spindles are so sensitive that if there is a misalignment in through coolant spindle machines, you really have a headache. You have to open the whole damn spindle and then realign the whole thing. So it is a downtime of at least 3 hours whenever this happens. So this was the thing. What do you notice here in the graph? This is what is the reading. This is what we derive out of all this information. What are we trying to see here? You can notice something very interesting here. You can see spindle load going to 0. You can see spindle speed going to 0. You can see servo speed going to 0, but servo load going very high. How can this happen? In principle, it cannot happen. First and foremost, the typical spindle servo interlock, what we do in a PLC program, is such that you stop servo first and spindle next. Is that not logical? You can't stop spindle first and then try to stop servo, right? Because once the movement of spindle stops, there's no more material removal, and there is maximum force. So every PLC programmer, on their principal definition of learning of PLC programming, they know how to design interlocks. The interlock always says stop servo first. That's exactly not happened here. This is stop spindle first and blunder. The minute you stop spindle first, the tool will break. Take it. Right? This was never observed. It's a brand new, rather 1 year is not very old, right, in machines. 100% imported Japanese machine. How do we capture this information? Is it actually possible to capture this information in real world? Can we actually do that? And that's exactly what we are trying to demonstrate. It's very, very important to understand how you can capture the data to identify these kind of problems. In this case, it's a post-issue analysis, which means accident already happened. You're doing a little bit of a post-mortem work. But fair enough. You're able to exactly identify. We told it to our customer. Our customer didn't believe this. He said, like, this new machine, it cannot happen. This 100% imported, fantastic brand, Japanese OEM machine. These mistakes don't happen. But they do happen. So the best part is we being an organization who is trying to work on data and all that. See, we can't go and convince all these people. So the simplest thing to do, pass the data. Data speaks for itself. They took 4 months. Our customer was anyway convinced immediately. They sent it to the OEM, to Japan. They took 4 months to respond. Finally, after 4 months, they acknowledged, saying that, well, there seems to be a problem. And then they corrected not just in my customer's location, but all over the world. My customer alone, in one specific line where we were working with them, was a $1 million savings for that financial year. Because that accident never ever happened again in any of the machines. So that is the power of data, if dealt with properly. I would like to put one word of caution here with respect to data. We did multiple analysis to get there. Okay, there was a huge learning curve for us in this project itself. First of all, this project was not meant for this purpose. It was meant for connectivity. We connected 350 odd CNC machines. We started fetching data. It was an incidental thing that happened to us because our customer was literally, the maintenance guys were our direct customers. They were crying. They were saying, like, this machine, I don't know, something happens once in a while accident. We'll have to do some extra arti for this and things like that. So what happened was, incidentally, by chance it happened. Incidentally, we were trying something else on high density data. See what happens when you fetch data from systems, there are multiple densities. When I say density, if you want to take temperature data, it can be low density. One sample in 1 hour, one sample in half an hour, one sample in 10 minutes. It's okay, it's enough. Because temperature as a parameter doesn't vary quickly. But if you're dealing with pressure, it doesn't work. You might have to go to 1 second, less than 1 second. You're dealing with currents, even lesser. You might have to go to milliseconds, 1 millisecond, 2 milliseconds, 10 milliseconds. So it is depending on multiple densities of data that matters. Incidentally, for this particular case, we had taken high density data. So that is the reason why we were able to capture this. This happened, the time delay between these two events was 40 milliseconds. So we were able to capture it luckily. Right, PLC 8 milliseconds, 18 milliseconds. the high-speed zone and the next zone, 8 milliseconds for one completion of one cycle, 18 milliseconds for everything else, right? So this was 2 cycles of the PLC. So you were supposed to capture within that. And that was the critical thing. So they had to put the interlock in the 8 millisecond stopping spindle after servo. That was the only requirement. So these are some of the interesting phenomena. What is the blueprint? How do we go about? I think earlier also there was something very similar. Very important, Gemba, start from the ground, define your objectives. That is when this whole space is going to work. We really have to get there. So most of you have a lot of requirements. So defining this requirement, I think earlier there was another conversation. I think we had a discussion saying that defining the objective is very, very critical. Well, we all understand that defining objective is also the most toughest, because you can only imagine what you want out of the system only to the extent of your understanding at that instant of time. And you are always evolving. Once you see the result, you start evolving. You said, "Arey, ye ho sakta hai, to ye bhi ho sakta hai. Why can't I do that?" So you will also be evolving with the implementation of the project. So naturally, your ask will keep increasing. So that is where this dilemma exists. And this is the biggest problem. So you will set an objective, but invariably it's very, very difficult to stop at that objective, because we ourselves are evolving with the project. As the project is executing, you're seeing the results, you're enjoying the output. Sometimes you're not so enjoying the output, and then you start evolving with the system. So the requirement keeps increasing from there on. So it's kind of a vicious loop. Can't really stick to that. So with that, we have to really get into the objective setting, grow with it, define the solution engineering, but the digital infrastructure is one big piece. It's one of the most important part of this whole process, because most often than not, defining the digital infrastructure is very difficult. Like what I think earlier, sir was mentioning, that you have, say, 1,000 machines. Each machine has 4 axes, X, Y, Z, and A, or whatever, sometimes 5 axes. How many sensors will you put? Now suppose you put the sensors. Who is going to maintain these sensors? It's a very complex thing, but still you have to put the sensors. There is no escape. But so this is where the whole dicey situation comes. So digital infrastructure definition is the most important thing. What is important? What needs to be digitized and how much? Not necessarily that in the first phase itself, I'll go ahead and do whole thing. Then you'll exhaust the budget. Nothing else will happen. You'll exhaust the budget. Management will not see great benefit. ROI cannot be defined. More or less, the project will start dwindling out. So phasing out is extremely important from the financial terms. We have experienced this multiple times, so I'm just trying to share that as an experience. And then we get into integration, process optimizations, ERP integration, and then comes digital twin. You cannot put cart before the horse. The primary reason why you cannot do that is because you won't get anything out of it. So it's an evolution in itself in that context. So I will kind of stop here, and a quick architecture, but I'll stop here and quickly go to some of the data points itself. How does the data look like? I will not run through all of this, but I'll just show you. First of all, a typical OE, all of this is fine. I'll start getting into specifics. One of the first things that you can focus on for all of your interest is getting the part count right. We all know that this is a simple thing, but it is easier said than done. We all know it. Why? Because you have something called as rework, you have something called as WIP, you have something called as tool change. So you have inspections. You have first of inspection, last of inspection, machine qualification, machine disqualification, requalification. So many things exist. Getting the part count right, and even you have dry runs. There is no part, you'll simply run the machine. Do you consider it as a part count? There are so many scenarios in a real manufacturing environment where what you think as capturing the part count is not the part count that has actually happened on the ground. That is the reason why we repeatedly say, in our experience, zero data loss assurance. Why we are so particular about zero data loss assurance is, in case of part count, even if one part is missed, your whole analysis goes for a toss. These are some of the sensitive parameters. Part count is extremely important because you can't miss a part in a production environment because it is being shipped to customer. How can you have something shipped to customer as one number and what your software shows is another number. It's just not possible, not acceptable. Even by one part, it's not acceptable. Out of a million, even one part difference is not acceptable. So we need to define what is acceptable and what is not acceptable. Part count is definitely not acceptable. You cannot have one part count difference, not acceptable. Because you're invoicing, you cannot connect it to ERP basically. If you have one part count difference, this data cannot be connected to ERP because there will be a mismatch. It will just not go through. So these are some of the parameters which are very important. Oh, I didn't notice that the PPT has not changed. Okay. So this is the part count definition. So this part count production data has to come from the production machine, not as a status information. If it comes as a status information, it will definitely not match your actual production number. This is given. There is no doubt about it. It has to be an information coming from the controller directly, without any human intervention. There should be zero human intervention, and it cannot be a Boolean thing. It cannot be a Boolean information. So this is with respect to how you can see data in multiple aspects. A typical Pareto, how you can define the reason codes, slow running, micro stoppages, and how that can be fed back into the production line for you to ensure that you have a better output. So this is something that can be an input for your improvement process. And then you have things like, I think you can then get into aspects like tool count, tool life management, where you have the selection of tool, selection of fixture, selection of insert, and selection of corners. How that is going to translate into defining the tool life and correcting the tool life. So what are the typical reasons for downtime? What are the typical reasons for the machine not producing? When you say downtime, downtime can be classified in multiple types. Necessary downtimes, unnecessary downtimes. Within necessary downtimes, all these setup and tool life, tool change and all will come under necessary downtimes. So how to optimize that will be your next piece of focus. With this, let's get to the actual data itself. How do we look at the data? Let's see how the data looks for you. Say, let's say, for example, temperature data. This is how your data will look. You can get to a specific thing, look at the specific parameter, which machine, which motor, which path, and which axis. You can get down to that level of drill down, and you know which is your machine and which is your particular motor that you need to focus on. 93 degrees on a servo motor 2, Z-axis. Clear scenario. One click, exactly you can pick which particular machine out of say 300, 400 machines that you have, which machine, which axis, which motor, which path is a problem. That is the power of data. So you can take a decision. You have actually taken a decision. And it gives you in the descending order outright, you can see what is your focus, which is your next machine and next machine and next machine. And you can predict when something is going to fail straightforward from here. The next important parameter, leakage resistance, insulation resistance. Many discussions have happened about how do you know the failure of servo motors. One of the straightforward case, insulation resistance. Sir also mentioned about the Weibull distribution, bathtub curve. So bathtub curve clearly says if the type of failures during initial installation, high failure rate, then you have stabilization, and then you have failures due to aging. In most machines, 3 years is the timeline. You all know that. I'm talking about machine tools, right? 3 years, post 3 years, you're getting into the aging cycles. And you're going to see, by the bathtub curve definition, you're going to see more failures. So anytime you have 3+ years machine, I think it's very, very important for you to have these kind of data. You're going to see huge difference. Our customers have seen humongous benefit. I'll show you an analysis around this, which says any implementation of digital transformation has these kind of situations, that you have parameters that can be monitored, you have parameters that might not be monitored yet. Out of our experience, you can see these numbers pretty clearly, 3,926 minutes of downtime before implementation of digital transformation. Post implementation, there were parameters monitored. We were able to save 2,053 minutes out of that 3,900 minutes. On the parameters monitored. Obviously, there are parameters that are not monitored. Everything cannot be done one shot. Irrespective of the amount of digitization, you will still have some parameters which are not monitored. out of the parameters monitored, we get into parameters prevented through IoT. What was actually done through IoT and what can be solved through IoT, which means IoT became an indicator to that. IoT did not actually identify it, but it became an indicator point. So we were able to identify that 960 minutes out of the 3,926 minutes was a direct saving from IoT implementation. Direct. Like insulation resistance, like temperature, direct savings. The other 1,093 minutes was a indirect savings, which means the IoT data was a pointer to that data, based on which you were able to save another 1,093 minutes. Of course, the 1,000, the other odd minutes, 1,824 minutes out of 874, out of the 218 minutes is just requiring additional hardware. So this is the point we are saying. Do we really need to add additional hardware or not? For 218 minutes, do you really want to add an additional hardware? It's your call. It's a business decision. Purely you can take a call. 1,388 minutes, you add hardware, you do whatever you want, you cannot save that at this point of time. So you need to have a different approach for that altogether. So this is how you can take decision based on how you are going to categorize your implementation. So you have for different, and I'm trying to show this because this is important because it is different for different manufacturing lines. See, in this line, out of the 607, if you take percentage basis, only this is 26% was a benefit. Earlier it was 38%. So there will be differences in percentages and benefits. And similarly, in another line, you have even more. You have 54% benefit. 54% of the time reduced. So with this, I think I will more or less touch upon the CPCPK part. I think quality, there were a couple of questions. So this is your CPCPK parameter wise. I'll just run through, not much time. If you group it, you're going to see per machine how the CPCPK can be picked up for every single parameter. 700 odd parameters, sample based, 100% inspection, CPCPK values. Specific CPCPK values for each parameter. And all the reds will exactly tell you what you need to do because it's a feedback, it's a closed loop quality, which means the CPCPK will be fed back to the machines for auto corrections. It's a 100% closed loop quality. And one other last part that I want to touch upon is, of course, yield. Yield is an important thing. When you look at yield, most of your machines are all not 100% yields. So there will be different yields. By looking at the yield, you can actually go back. This is also a closed loop mechanism. How to use yield information to correct your process, identifying the bottlenecks, shift-wise, line-wise, and so on and so forth. And the last one is the decomposition tree, another tool which can be effectively utilized to identify the root cause in quality specifically, but of course it can be used anywhere, in quality to understand which particular part, it's at the barcode level. So I just want you to understand that it's at the part level. Which particular part at which point of time was passed through which gauge, which machine, which line, which operator, and what is the root cause of that particular problem. So you have a complete end-to-end traceability of this information. So with this, I think I will come to the end of the definition of what we are trying to talk about in terms of decision making based on quality, based on data-based decision making. So with this, I would like to close my conversation. Thank you all for patient hearing.
Okay, so thank you, Kalyan sir. And quickly, we now welcome our next speaker, Mr. Laksh Malhotra. A brief about Mr. Laksh Malhotra. With over 13 years of dedicated experience in the field of industrial automation, Laksh has established a proven track record as a versatile and accomplished professional. His journey in the industry began in 2010 as an automation engineer, and since then, Laksh has consistently evolved and excelled in various roles, contributing significantly to the advancement of automation technologies. Laksh plays a pivotal part in the strategic development and market positioning of the cutting-edge technologies and is responsible for market analysis, product lifecycle management, and collaboration with cross-functional teams to ensure the successful integration and adoption for the products in industrial settings. Currently serving as the product manager at Wepril-Fuchs FAPL, Laksh has taken on the responsibility of overseeing smart connected products including RFID, smart machine vision camera, IO link sensor, and industrial gateway. Over to you, Mr. Laksh Malhotra. Presentation maker. आप ले लो. ये निकलता नहीं. एक मिनट ओपन करो. स्लाइड इससे चेंज हो रही है. हाँ, स्लाइड आप इससे चेंज हो सकती है. वो पॉइंट लगाना पड़ेगा.
Okay, so good afternoon to everyone, and thanks for this opportunity that AIA has given to us, and especially FSM, Foundation for Smart Manufacturing. So today, all of our speakers have discussed about AI, somebody has discussed about legacy machines. So I just want to touch upon one of the two processes in the digitalized process tracking. One is the digital e-Kanban, and one of them is the variant management, which I have experienced in one of the automotive segment, and I'm also be responsible for industry management as an automotive. So to start with, the first agenda is that how this digital Kanban digitalization look like, what will be the flow, and what is the e-Kanban and 4.0, and what are the benefits, and the harmonized sensors fusion with these kind of technology can happen. And then the next part will be the variant management and the flow of those component tracking and solution itself and the key benefits out of that. So I'll take you to journey of that lean production. Lean production, which says about the pull-based approach, which is a pull-based approach which is actually been implemented in our all manufacturing plants and all those things. And currently, these sites of implementation being done using a paper card technology. There is you can say a paper card which is being tracked and which is being sent from one location to another and from one assembly station to another. And then based on that, the flow of that material will be tracked, and the flow of that material will be is that whether my production is working seamlessly based on the goods of the material which I want to receive, and whether those material receipts are on time, or which is a just-in-time approach. And when it is a just-in-time approach, and that sort of concept is very traditional in today's industry. So how we can make that more digital, more real time based on tracking, which is an RTLS tracking, and the future of that tracking is that it's an open locating standard, which will be connected to one uniform standard, which is an Omlock standard. Then coming up to the approach of the traditional flow, which is a Kanban flow, a paper card flow. So most of us went to the supermarket approach. A supermarket is such of thing, they have a bin and there is a customer order, and that customer order will be given to some sort of a worker. Worker will give to that Kanban kit, and then Kanban kit will go to the production. The production will start based on those raw material, and then it will send back to the secondary workstation where they assemble it, and then they assemble it back, and then it order is shipped. So there is a traditional approach that they get the raw material out of the store, then based on that raw material, when the raw material gets utilized, then they will send a request for replenishment that, okay, I need more goods to fulfill all those things. And then those sort of approach for utilizing to fulfill that production, it is more important. And what happened in that journey, what happened is that when you are sometimes the raw material, when you try to go at that particular location at that particular time, that you are like underutilized and you don't have raw material which is there at that particular moment. And if it is there, then you are not able to put it into your ERP, onto your IT systems. And what happened, that the shop floor shows that we have a 10 materials, and the actually IT system shows that it is been already buffered. There is so much of other materials also there. So there will be a lack of like connected material storage and whatever the storage which is there, and how to replenish that thing. So important thing is that to do that is another stage which we have implemented is a barcode based system. So a barcode based system comes into that picture when a bin is there and a material comes on a bin for the production, and then a person is responsible to scan that bin, and then he has to push that system back to the IT domain. And now the responsibility in that particular moment is upon the worker, that how he has to do that how much he is responsible of doing that. So if he didn't do that, if he stored those bins for a next hour, for 20 hour, or maybe for 20 minutes next and 1 hour, and he wait for the next time that, okay, my next when my next shift comes, then I do this things, I'll shift that material to my ERP. Then at that particular time there will be a vulnerabilities, and there will be some sort of problems occurs that these sink and source doesn't match. And to make it happen, we created a sort of things, or we try to build an ecosystem where we can real-time track it. And we say that a digital trolley, or you can have a digital Kanban racks. And how to make these things like in an IoT format with replenishment of goods in a more like you can say in an IoT way is the concept of this 4.0. So to make it happen, the concept comes that let's have a real-time tracking of a bin from the stage when it comes from the store, coming into the assembly line. Maybe it can be a handy RFID which track the bins on a real time, and the same time when it tries to put that material, maybe if it is an X material, if try to scan at the bin, and the bin has another RFID which is tries to scan it, and then based on that material it tells that you have to place in that bin. If you try to place in the next other bin, it will give you a signal that you have placed on a wrong bin, so that in a real time the material get updated on a stock level, and that stock level will be sent to your SAP and ERP or to the other business layer. So means you can have a track record of complete like uniform tracking of your complete system. Even it can be a raw material, it can be in the form of a trolley, it can be in the form of a big tool sets, or big, maybe you can say bucket systems where you can carry the things manually through AGVs. So making it more autonomous by using an AGV, transporting into one location to another, and then putting in that system in a row and column scenario, so that those verticals can match, and then easily updating that information within those milliseconds. So the thing has been done is that we made a concept sort of a digital trolley. So let's give you an example of that. I am like a store person. I come with a trolley. I am on the back side of that session, I have a bin which is an RFID tag. I scan with the trolley tell me that, okay, I have to pin. Once I put it onto the bin, it is a smart bin. The bin is located with sort of a grid sensors. When it enters into that grid, it's a pull pick to light or put pick to light system sort of send. Or once I put it into that bin, the beams give you a signal 1 and it gets updated in the ERP at that moment. And once the assembly point who wants to use that material for his production, he goes on the other end of the bin. He scan the same bin based on his request of the material, based on the type of variant he want to manufacture. He scan the same bin, and when he pick out and use the material, and then he put it into the bottom of the bin, which gives immediately signal to the store. He don't have to take those barcodes or cards back to the store and put it into manually into the system, so that he get a request and then the material get filled. So what happened in that time, the lead time become increased. In those kind of scenarios, the lead time becomes shorter, and you can easily fulfill, or you can fulfill your materials, and you can keep your production cycles in a closed loop. So means the control cycle keeps moving, and you will manage your raw material on time. So what the benefit out of that we get it, that we have end-to-end digitalization of from the store, from the partner, from who has given you the order, and you can even give that digital order update about that. When you order like on an Amazon, it give you a track about your parcel, it has been delivered or something. But still there are some process under that which is not mapped to you. To make that manufacturing more digital, we can do that. We can measure all the process while moving, while on the rack, and while assembly. These kind of end-to-end digitalization can be happen with an RTLS system with lot of other technology like GNSS and UWP and RFIDs. And it gives the flexibility, and we can make a custom fit solution like this bin, or maybe like another. It's not like a mandatory you have to make it like that. In a Kanban, there is a multiple rack, like in maybe 50 or 100 racks, and every assembly points have to take different tools and they have to update for replenishment. So you can make a custom fit solution which makes those processes optimized. So what things which we have used? We used intelligent sensors, we use the edge connectivity, and the business cloud layer, means the data is centralized to one layer, which is maybe a edge layer, or maybe or API, or maybe you can say a one service layer where the condition monitoring of the sensors happens, where the permission management happens, and where we have also the access management, and also we can also have a quality data of their sensors. And after that, these goes to the main business layer. It can be any like ERP, SAP, MES, and whatever the way you want to take it. So this is one of that example. Now coming up to my second very good application is to drive for a variant management. This is we did for one of the excavator company, and where we want to track the inventory stage. So the last speaker just told about that, how that inventory can be managed, how we can track the quality status directly with that part, what is happening with which stage, and how to monitor, and what is the workflow of that process, how to manage that. So every mother part has a child category of those parts which need to be assembled, and tracking of those child part to deliver a material in a right time comes in the main KPI, which is a delivery KPI. So what is that process looks like? So its general process is about the store, which give you the mainframe material, has a variant ID. It passes from the stage like tacking line, the pre-weld, the robo, and it goes to the SIP and then go to the paint line. So during that process, entering to the paint shop after welding, there are some parameters that after these things we need to enter the paint at that particular tacking time. We cannot delay that. There are processes we need to measure it. So to act upon those processes, we made it a component tracking solution. Based on the variant, let's track the child part which had been assembled and track the complete variant and update on the SAP and ERP. And because when this material, when it get painted, when it become a finished good, when it go out of the plant, So back after the 4 years, if we want to track which child part because of that it happened, there's a warranty clause, or maybe any comes and any like customer complaint comes. So based on that warranty clause, can we track these processes? What happened? Who is the person who checked the inventory? Who has scanned the serial number, and which stage it has happened? So let me explain the things. So this is the way where the mainframe start. The mainframe comes to has 3 serial barcodes. One is the serial ID, one is the variant ID, and the variant ID after that is the mainframe ID. These mainframe ID, when it goes to this any of this stacking, there is a shuttle which is with an RFID which moves, and when it moves, it identifies the tag on the stacking station that okay, now this mainframe came to this stacking station and the process is happening here. After the process happens, all the parameters with that station is being mapped, and then after things done, it goes to this inventory conveyor. There the serial number is scanned and it get married, and when it get married, it simultaneously sent to data to one of the SAP or one of the software. Then it goes to another station. The same thing happens, the pre-weld line. Further on, it goes to the robo line, and then it has a feasibility for the operator to select, okay, for which robo operation I have to do. I select a robo, I'll put it into the system, and the same system goes to this software. So means which robot has been operated at during that time, which pre-weld line and which pre-weld station has done that, and which stacking line station had done that. And those all string data will be stored in a database for future and further analysis, what all parameters has been happened. And then after this robo, it goes to the main paint station. So means, you know that my variant has been tracked based on my child component throughout this process, and this tracking within a short manufacturing line can be done, not with a very huge amount of putting so many of IIoT devices or edge devices or something. By using a simple digital connected devices, we can track the process and we can see the anomalies and what are the things which has been geoparadized, means what are the process get geoparadized because of this. So using this, we find out those advantages. What are the benefits out of that? We get an inventory count every stage. We know that inventory is counted at every stage, and we can have a variant wise inventory. And even the aging, let's suppose my main frame came from the store at this particular time. So after 4 years, all the records of that mainframe, what are the other parts of the mainframe against that serial number can be also tagged, and that the aging of those parts can be done. And it is a process of quality and what is planned versus actual at that particular time. Means I have a planning sheet and I have an actual system. So what is a plan versus actual system? At that time, I can track on complete real-time system. So this is about the two sort of scenario, process and digitized tracking, where the data can be the data is from the sensors and intelligent sensors or RFID, like from the eCanban, like how the goods can be flowing in and out and can be tracked real time, and that flow of data is the real you can say asset of decision making. And this is the process of making a digital Kanban system. And the another will be the real time tracking of a component and to make the variant management more smoother. So this is from my end. So thank you.
Thank you, Laksh. We now invite our next speaker, Mr. Anirudh Katkul. Mr. Anirudh, an accomplished executive director in cybersecurity at PwC, brings over 33 years of experience with a focus on driving intelligent automation in manufacturing ecosystems. His expertise encompasses more core manufacturing processes, supply chain, and supplier manufacturing processes, leveraging technologies like edge control, IIoT, MES, and physical math models for digital transformation. His extensive global experience includes leading digital transformations across regions like APAC, North America, and Middle East and South Asia, with a consultative approach prioritizing technology interventions aligned with the business KPIs. So once again, I'm making full use of the technology, and I'll be taking forward Mr. Anirudh on the line.
Hi, good afternoon, everybody. Am I audible and visible?
So just 1 minute. I'm just putting you on the line. Okay, let's go. Okay, so you're on the line.
Yeah. So, am I audible and am I visible?
Let me check your speakers.
Hello.
Yes, sir.
Yeah. Okay. So unfortunately, I can't see anybody on the screen, so I'm sorry. I'll just have a brief introduction about myself. I'm Aniruddha Katkul. I work with PricewaterhouseCoopers Services in the cybersecurity area. I've been 3 odd decades in this industry, and I've been working now last 1 year on a couple of interesting domains. One is related to cybersecurity in manufacturing, and the other one is related to IIoT and connected vehicles. So I think these are topics of heavy interest to everybody. And I'm sorry for lack of audience reaction. I might pause some time, and I will appreciate if somebody from the other side would want to stop me with a question. Please feel free to do so, because I can't see anybody. But please feel free to stop me. The subject that we are, I think today I was tasked to speak about primarily, data-driven decisions and process maturity. And that's a topic where I have been still learning and, to be very honest, struggling quite a lot, so that we get good data, and we can be very sure of the processes which give us the data. When we are living in the world of what is now called as Gen AI, which is expected to kind of overtake uh, the gap in skills and knowledge as far as newspaper items go. But the other thing we are actually seeing is that there is overwhelming amount of expectations about how data would be helpful for all organizations, people, support systems, so that our
Excuse me, sir.
decision making process is richer.
Mr.
Uh,
Kotkal, I'm sorry to disturb you.
yeah.
Sir, there is some issue with the voice clarity. Can you please speak a bit loud, sir?
Just give me 1 second. Let me switch my camera.
Yeah.
Just give me 1 second.
यहाँ से तो फुल किया हुआ है मैंने. हेलो. कौन सा वाला से? ठीक है, वो बोलेंगे तो पता चलेगा. वो कह रहे हैं उधर से बोलेंगे तो पता. उधर से वॉइस आएगी तो. So we have managed to get your voice on the board. ठीक है. कैप्शन
सेटिंग तो इसमें भी नहीं है.
ठीक है. Mr. Kodkar, am I audible?
उनकी वॉइस बोलेंगे जब ना वॉइस आएगी. सब कुछ ठीक है.
Yeah. But he's showing online now. He is available. You can try rejoining, sir. Kalyan sir, is he retrying? अभी यूज़ नहीं कर रहा. ये है मेरे हाथ में. So you can please turn on your mic and video.
Hello, can you hear me now? Hello? Hello? Hello?
आवाज आ नहीं रही है उनकी नहीं आ रही
बोलेंगे जब ना वॉइस आएगी
नहीं म्यूट नहीं है म्यूट होता तो यहाँ पे देखता
Some funny thing here.
सर बोलेंगे जब वॉइस आएगी ना
Oh.
Okay.
Can you see me now?
Yes sir, we can see you.
Yeah, so there seems to be some glitch. The previous connect got disconnected and it's not allowing me to log in again. Somehow it is allowed now. Sorry for that.
अभी क्या जल्दी लगा भाई
ऊपर से जाके वॉल्यूम को
Can I continue? Hello?
Yes sir.
Can I continue?
Just 1 minute sir.
Okay.
I'm not able to get your voice actually.
Can you do an offline? Just take it out. नहीं, just take it outside. We'll come back again. आप लोग टेस्ट अलग से करो ना.
एक मिनट
ये आपके वीडियो कॉलिंग भी थी क्या?
वीडियो कॉल है.
यहाँ से हमने चेक कर लिया.
अच्छा ठीक है.
Hello?
Anirudh, we'll come back to you when this is resolved.
यहाँ से
If that's okay with you.
स्पीकर ये करना था.
Okay.
करना था.
They'll take it offline, but we want to set
अभी
the
भी आई नहीं
system
आया
first.
यहाँ से चेक कर लो.
No, don't disconnect.
Okay.
Naman, yeah.
अब बोलने के लिए अब बोलना.
Sir, please speak now on the mic.
Hello? Hello?
क्लियर.
Yeah, you're audible now, sir.
अंदर सेटिंग नहीं करेगी ना उसकी.
Am I audible now?
Yes, sir, you are audible.
Fine. So can I continue with the discussion we had a few seconds back before I got disconnected?
फुल कर देना.
यहाँ से फुल है.
ऊपर से मैंने फुल कर रखी है और बढ़ा दूंगा मैं. और फुल कर देना.
Hello?
Yes, sir.
Should I continue?
Yes, sir, please continue.
Yeah.
Mic से दूर से.
So I'm again sorry, we are living in a world of so-called great connectivity, and we can see that this is actually a lot difficult when you are actually trying to connect. It is not possible that all the planning can be done beforehand. But when we are trying to get this kind of by the way, Naman, can I see something else other than the curtain, because I can't see anything else?
Sir, I can see you. Provided if you wish to see the audience.
हाँ, मुझे समझ में नहीं आ रहा है मैं बात किससे कर रहा हूँ.
Okay. Fine, sir. I'll help you with it.
That would be so nice. Ah, wow, this is great. So this is fantastic, and I'm extremely sorry that this digital connectivity is taking so much of time when we should be doing this in seconds, but that's how real life is. So I'll just continue with the discussion of process maturity. Obviously, process maturity now we have seen is not something easy to do. Irrespective of the best plans we have, process maturity can really throw a spanner in the best of your ideas and visions, so to say. And when we talk of data-driven decision making, data-driven or data-enabled decisions will work only when there is data. That is obvious, but data needs to come actually from signals when it comes to manufacturing at least. And all of you are from manufacturing, I suppose. So the thing about getting data on board is itself a big story. While the dashboards that we are talking about, or which managements in corporates demand to have, would be always nice to have. The journey itself is probably worth a thesis or two, particularly because the journey from a signal to data and from data to insights, this is something which takes a lot of time. I am going to talk about two or three such cases which Mr. Wadhwa and uh, the team there has said would be relevant for this audience. I suppose most of you are experts from your individual areas and decision makers. So I'll speak about hopefully three areas which will connect, three examples which will connect. Uh, the first thing is, in a data world, I just spoke about signal to data, and there is a myth that a lot of data is available. The first thing is that, at least I have to be honest here and say, from manufacturing processes, the data is not available in abundance. The data is almost like gold, where you have to dig it from the darkest corners and probably take it out from areas which you have never thought of. And that itself is a topic where you have to have tremendous amount of instrumentation skill sets and see wherever data is even available, for example from PLCs or from your SCADA, whether that data is time contexted, whether that data is parameter contexted, and then you would be able to utilize it as insightful data. The second thing is related to the processes. Most of the manufacturing processes, I would call them legacy processes, the design of the processes is based on production outcomes. None of them are tuned to the idea that you need to actually give data to somebody so that you can have insight from your processes, which is beyond what the machine manufacturer gives. So, with that particular bias, I would call it an outcome bias. You need to really look at what is the kind of data and insighting you need from the lower quadrant of individual machine perspective to the top quadrant of having a decision maker understand what is going on at the process level. You need to have a outcome to data driven uh, change in the thought process and even the methodology, bring about maybe corrections in the process which would almost go to the design level. And then we talk about data driven decision systems. So in my current experience, I would like to speak about a couple of areas in the automotive industry which on which I have worked. One was an area where uh, we thought of doing something as simple as an online gauging system. So this was related to CNCs, where maybe two parts had to be assembled, and one part was being made on a set of CNCs, and the other part was being made on a set of CNCs. These were batches. The whole outcome was, when these are assembled together, would we go be able to go beyond what the tolerance fit is giving and do something which is something much more than that. So in this area, we actually started looking at what would be the data required to do this process, what would be the parameters which are needed, and what we ended up was looking at whether there is a pattern when you are making a good machine or when you are having a good machining or an ideal machining. So that is the golden signature. So we did discover this after a lot of activity. We had to work on around 3 or 4 thousand pieces on the CNCs, which took around 1.5 years to just get the data. And to get the data also was a process by itself, because we had to make it relevant to whatever coordinates we are talking about. Meaning, if you are having a borehole dimension, then what would be the data that is required? Whether the machine is giving it, whether the granularity is there, and whether the data that you are actually getting is proper data. That means even the data can be erroneous was a learning we had. We always believed that the data which is coming from the machine is perfect data, but we realized that that is not true. Sometimes even that data has to be corrected. So once that was done, after a lot of process, what we got into was an online gauging system. Meaning, before you set the new product, and whatever we have learned from the past few hundred products, we would be able to correct the process parameters so that the next product which was machined, we could predict the tolerance of what dimension would be drilled onto the machine. This was the first of its kind that we got. Even today, after a few years, I have not seen any mention of that anywhere. No papers written anywhere. So this was something which I can truthfully say I have not seen repeated. It was a massive task, of course, but that proved to be a kind of a benchmark because such an expansive project, we of course used tools like MATLAB to do that, and we could predict the next set of boreholes to the accuracy of 5 microns, to the tolerance of 5 microns within an accuracy of 92%. So this was an insight we got that you can actually predict what is the quality of the process that you are doing on an already highly complicated and highly perfect machine, which is CNCs. And that result was out for us. The next thing that we had to do was make it something which could be affordable, because the process that we did was a little expensive. And that was the next step where we used statistical measures using fundamentals of Six Sigma or statistical analysis. And we started bringing in a little amount of normalization in the computation so that we could use those processes on a much more democratized basis. So the net result of these two major activities we did was as follows. When we do engine testing, diesel engines and petrol engines, in many cases companies continue to do hot testing and load testing, and before that there is something called as cold testing. Idea would be not to do hot testing and load testing because it doesn't just lose time, it makes you use a lot of fossil fuels, and you need to have a better decision making system there, which says once you do the cold testing, either you check it further or you just push it out in the market. With these processes which I just now told you, we could do that because the data that we were getting was perfect. The processes that were throwing the data were also perfected over a period of time, and subsequently we had 300 and odd parameters of the engine, which started to give us, after a little amount of machine learning based analysis, is the engine okay or not okay. So the decision making systems were entirely data driven, and not only that, the decision making systems also told us in those cases where there was a problem of requiring further testing for the engine, what were the parameters back in the process which were not good. And it pointed back to the process which, as I told you in the first phase, we had already perfected. So that whole cycle was supported by a data driven decision making process. So to summarize, getting the data was not easy. Getting the granularity of the data was a task by itself. It took a lot of time, more than 1.5 years, to be able to get the first phase of results out. But subsequently, using statistical analysis and a combination of measures and knowing the system, we could graduate to a process where the operator's decision, which was based on his heuristics and his intelligence, could be augmented and made better with the help of these data driven decision systems. And the process which was leading to that particular test could also be improved. So this is just one set of examples which I wanted to bring in front of you to speak about process maturity and data-driven decision systems. I will take a small pause here because I think I have already used my time, but I'll just pause here and see whether this resonates with anybody and if there are any questions here. Mr. Naman, Mr. Ranu, Wadhwa, please let me know uh, how do we proceed.
Inputs, and then we have to put an alternate plan, we'll continue this session a little later. So we are taking you off the line right now, but Kalyan will be in touch with you. I need to start the next session. Our speaker needs to go, so I'm taking special permission from this entire team of session 4 to introduce this new emergency action. Really apologize for a little mess at our end. So Anirudh, you can go off the line from this system, and Kalyan will be with you on the phone line. Okay?
Sure.
Thank you. Bye-bye. Can we give a big round of applause to Anirudh? Okay, friends, we need to change track a little bit. We have the last session on skills, and we also have a tour of FSM lab. So what we are going to do is, we are going to take 2 separate actions. One is that the Maruti team, one batch will like to go to the workshop immediately. So you can contact Akash and Amit, who are standing at the back. We will introduce a speaker who was to be in the last session, but he has to go for a customer meeting. Can I introduce Mr. Neeraj Hans? He is the Chief Operating Officer of Sandhar Technologies. He is one of the informal advisors to our project way back in 2017 when we conceived the idea. His role is not only limited to Sandhar, but the entire manufacturing industry as a stalwart in bringing the skill initiatives. He not only works for ASTC, but also with CII. And I would like him to share a little bit about the challenges of skilling given this technology, and then we'll continue the session after him. Mr. Neeraj, for you.
Thank you, Adwa sir. I think Mr. Adwa has spoken more than what I am. So thank you so much for the kind words, sir. So before it starts, may I request some of you to let me understand the kind of audience we have now. How many of you are users of IoT? How many of you are providers of services? Okay, others are for academic intelligence, understand. So I represent Sandhar Technologies actually. Sandhar, some of you might be aware, if not aware, we are into automotive tier 1 component manufacturing space, catering to almost all the OEMs in India, whether 2-wheeler, 3-wheeler, 4-wheeler, tractor, trucks, with almost more than 300 SKUs. We are into different product range, locks, mirrors, door handle, latches, hinges, relays, sheet metal, painting, powder coating, plastics. Technology-wise, manufacturing-wise, we are into quite diverse space with almost 50 plants, not only in India, but also in Spain, Mexico, Romania, Poland also. So with this kind of, size of the business and the size of geography, customer, product range, it was quite evident for us to get into some kind of technological support. So how it started was that for me, what I understood, so I'll be speaking more not on the theory side, maybe what we experienced as a company on smart manufacturing, we call it, not precisely IoT or Industry 4.0 or 5.0, no. Only whatever little bit we could understand from that. So I'll limit it that only as a user experience, not as a service provider point of view. So it's a small there was a temple, so sort of puja was going on there. So one cat came inside the center, and they started disturbing all pujaris. So one of the pujari told the other one, okay, why don't you manage it? So they took it, they tied the neck of the cat with a rope and tied it with a pillar. So they kept on doing this activity almost every day. So this was a facility for them so that they could do the puja easily. So it happened for months, weeks, months. In between, staff changed, new pujaris came, they saw the people doing it, so they also started doing that. So one fine day, cat died. So they all were looking at each other, now how do we do puja? So they went to market and they brought a new cat to do their puja. So they thought it was a ritual. So what I'm trying to convey here is that if we keep on doing the things the way we have been doing it, we will never get into the smart manufacturing or industry 4.0 or all those things, because everything starts from mindset. So I think IoT or industry 4.0 in India, we have been talking, if I'm not wrong, almost more than a decade now. And whenever we go to some session, we speak, everybody wants to understand how to start it, where to start from. And then some gentleman was saying that people have reached IoT industry 5.0 also. So Mr. Jha was very, I think, right in saying that whether 5.0 comes, it doesn't make the earlier thing obsolete. So every day is a new day. So where we have to start. So what we understood was that, when we say that we have to do something on that, so we have to, think smart, what makes anything smart. So we call a smart man, smart human, let me put it in that way, smart human. Smart human means if he feels heat, he will tell you, I am feeling hot. If he feels temperature, he will tell you, I am feeling temperature, I am feeling cold. So if he tells you that, you miss, as a doctor, he goes to doctor. Doctor understands, then he gives a medicine, he takes a medicine and then becomes curing. Same thing if I apply to the machine. Machine can't speak, machine feels heat, machine also can feel vibration, machine can also draw more current, but it can't tell you. So what we understood as a company from the smartness is that once you equip some equipment with a sensor through which it can reflect back to you its feeling or its condition, you are making it smart. So this is how I try to correlate between the smart human and a smart machine. Once you put all those sensors on that, because sensors nowadays are available. I mean, gone are the days where one sensor means one piece, one big amount. Now I think my friends will all agree, whosoever are dealing with sensors. It's not like that, but maybe we can use it rupees per kg kind of thing. It's not exactly like that, but the cost of sensors has come down to up to that level. So we just tried to use that thing in our machine, our factory also. So where to start from? So what we did was, if you see the logo here, we tried to create this logo also. On one side, left side, you see Sandhar Smart Manufacturing, a human hand with a robotics hand. We are into assembly business. So what we do is basically we buy parts from our suppliers based on our design, and we assemble that and we convert it into a product. Locks, mirrors, door handles, latches, hinges, as I told you. And factually, we make more than 50,000 lock sets every day. And we make 150,000 mirrors every day. And our dispatches are almost every hour. So keeping all those things in mind, we had to find out our own solution. So I'll not get into this thing now. Everybody knows Internet of Things, smart factory, digital revolution. I think telling this thing means, again, I'm repeating same thing what my earlier speakers have already spoken to all of you. So Sandhar initiative towards Industry 4.0. We precisely gave a definition to it, connected manufacturing earlier. So within our plant, we have machines which takes care of the key manufacturing. We make our keys in-house. Then we have an assembly line for the locks. Then we have stores for BOP as well as for the FG products. So we went step by step. We thought let's start with the connected manufacturing first, means connecting all the machines together so that we can have the status of those machines on real-time basis in our laptops or in our screen. So what we did was, we never went to somebody to give me a solution which is plug and play. We wanted really to get into it, full immersion, what you call. So we created one CFT where we had team from production, from maintenance, from quality, and also these people were equipped with some graduate engineer trainees as well. So just gave them assignment, okay, you study it and how it works. Then we got some help from CII also, ECMA also. Knowledge is all available everywhere, but idea was to absorb that knowledge to suit our requirement. So assembly automation we did by putting sensors on every station. So we were more focusing on the quantity and the quality. Quantity, once that part passes through the sensor, you can get the counting done. But quality wise, we had to put those fixtures for those sensors on our inspection fixtures on the line, so that we could get the qualitative and quantitative both data on our laptops also. Material traceability was another area where we did it all in isolation. Let me be very candid about it. We did not do entire thing in one go, that the whole plant we are trying to convert it. So we went with connected manufacturing first, then we went for the assembly line, and then we went for the material traceability, track and tracing system. So if you see here, two things are shown, two rectangles are shown here. Right side you see measure, communicate, collect and analyze. On the left side you see act and predict and act. So predict and act is AI part for us, for everybody I'm sure. But on the right side is more on the system side. So AI we did not go to it initially. We went with HI. Some of my friends who may say, what is HI? So we went for human intelligence, not artificial intelligence. Data was available, data was analyzed by our own engineers, but decision was taken based on that data. And I'll show you some examples if possible here. So through this, we were able to get all this data on our screen in the shop floor also, individually on my office also. So here you can see on production data, quality data, maintenance data and analytics. Analytics was done by our set of engineers. Benefits, of course, it's evident: shop floor visibility and machine monitoring, OEE, CBM, power consumption. Once you're able to consume or able to see how much this machine is consuming power, every day if it's consuming certain level, suppose 200 ampere, example, but suddenly it starts consuming 300 ampere or 350 ampere, means something is different, which is giving you a data that a machine is consuming more. Why it is consuming more? We have to go to it and analyze it. So these kind of board, if you see the dashboard, these were all drafted by our own team. We gave it to our service provider, which was a startup company. We met everybody in the system, in the market, biggies of the biggies also, and smallest of smallest also, startups also. So we found more, to have a hands-on experience with our own team also. And we gave our own database to them. Okay, please convert this thing we want to see on the dashboard. So here you see, this is a very old slide when we started the things in 2000, if I'm not wrong, 18, something like that period, 18, 19. So here you see three machines. Three machines are showing me three different data. There are three bars for three machines. So green means machine is running, yellow means planned shutdown, red means breakdown. So when we saw this, why in the morning machine is showing yellow? So the answer I was given was that machine is under cleaning for 35 to 40 minutes. The old day chips were being cleaned. So why can't we do something where we have to reduce this yellow band to minimum? So we converted that cleaning process to the quick change tray system in the bottom of the machine, and that helped us a lot to convert keep the machine running. And then even the workers were even conscious to not to see the yellow band on the bar here. Even during the tea time also they were able to collaborate with each other so that there is no yellow bar. So that was a kind of productivity which we started doing. Alerts notification on real-time basis. It goes by email also, by SMS also to the people. So idea was, we understood the basic concept, what all is required to monitor it. So moving away from that, pen and paper, Excel sheets in the evening, and then manipulating them to suit the, suitability of the supervisor, first to the production manager, then production manager to plant head, then plant head to CEO. So all those manipulations were finished. And directly if you see the data, you are able to have the real feedback as well. So preventive maintenance alert also, number of runs or number of cycles, whatever you can decide. Based on that, you will start getting the preventive alert as well for the machine. Daily energy consumption, it's a good, I think, data. Every machine is consuming some data, some energy. If you see on real-time basis, if you see, I think once you keep on seeing the data, it pushes you to think in certain direction. You see certain trends. And once you see trends, you are able to decide, okay, this is the right trend now. Suppose something goes beyond that normal trend, means something is going to happen, so you better stop it there. Section-wise report you can see. We had molding section, we had milling section, we had key biting section, machine by machine, operator by operator. Even 7 to 8, how much production, one machine, 8 to 9, how much production, 9 to 10, how much production. So this data for one machine is similar data for all the machines. So you can have a, which operator is doing badmashi or which machine is doing badmashi. So kind of thing you can focus on that area. Otherwise, the routine was morning we have to make so many people guys, so many products. In the evening, they will say, sir, so much made, dispatched. Thank you so much. It was made at 6 o'clock, 7 o'clock, 8 o'clock, overtime, no overtime, nobody knew. But now we are able to know. Machine-wise history card, it comes. So visualization benefit, I told you already. This yellow, you can see the circle there. So this is example like we started that time. And then milling production benefits of brass scrap management collection process also was started. So this was kind of the team which we started with, and we started working on that. And we started working, see, ultimately the crux is that how you want to start and where to start from. Identify your own problems and give a digital solution to that problem. I think you are there. So from there we can start it. Thank you so much.
Thank you, sir, for accommodating this delay, and we hope the audience got good value listening to the case study. Thank you very much for your insights.
Thanks to you. Thank you so much. Thank you. Thank you.
Now we'll request the previous team to come back on stage and do a quick wrap-up. So may I request Sandeep Dongre, who's a fellow IIT alumni, also a graduate of IIM, and rich experience in manufacturing, including our famous Maruti Udyog. He has worked with Lear Corporation. He's worked with some other manufacturing companies, Johnson Controls, and now he's an independent consultant. He also is an FSM ambassador, given the fact that he is an IIT graduate, and I take my liberties to count on him. So I'd like him to take his seat. And with his opening remarks, he will conclude the session. Can I also request Kalyan to come on stage? And Laksh. Over to you, Sandeep. You have the mic? Yeah.
Hello? Hello? Am I audible? Yes, sir. Yeah, yeah. So I'll start by thanking first the FSM team, Mr. Anup Vadhva and Professor Jha. So for providing me this opportunity, for also and before this opportunity providing me their time so that I could communicate with them what I always like to do for Industry 4.0 after my retirement. So thank you for that. Will I would like, and it was for Mr. Kalyan, it was an excellent presentation from your side. I mean, it was you have taken a case starting at the start of the factory, inside of the gate to the outside of the gate, from in to out, raw material in to FG out, and all the equipments that come in between, and how you can track and everything. That was an excellent way to really track the data on a very real-time basis, and not only track but also try to make sense of the data and the traceability that goes along with it. And Lakshya, that was a wonderful thing. Never thought about it. In fact, I have been into manufacturing for so much long time. Then never thought that we could also have a e-Kanban, because I have always been into cars Kanban. So that was a very good insight of how the technology can be used for bins and for the trolleys, and how we can track them on a real-time basis. Excellent. So I would first ask Lakshya, this particular concept of the e-Kanban, is it been used somewhere in industry already in India, or is it something you are trying to develop for somebody now? That is.
Yeah. So thanks for the question, and it's actually every time comes into my mind also that when people talk about Kanban, when I go to an automotive industry, we see so many of racks, like the old racking system. They made some sort of a semi-automatic system using pick-to-light sensor, small PLCs, making traditionally to slight smarter, and then came into mind. I want to tell them that these kind of like story and like a picture, which we started with Bosch. First of all, Bosch it's not in India, it's in Germany. We started with Bosch with a collaborative approach within pan-India and Asian community also. So they have their Nexseed sort of layer, which we are trying to implement in India with the standard called Omlox. Omlox, which I want to tell you, is an open standard right now for real-time locating standards. It's like you can locate yourself real-time every time where you are. So which is an open standard for the partners who want to collaborate. So not only RFID, I'm not talking about that it's only an RFID. It can be indoor technology, it can be UWB, it can be an outdoor GNSS GPS, and it can be barcode. With that barcode, you can like understand that how while scanning a barcode from a handle, having an antenna like a UWP, you can immediately scan data. Barcode can be attached to that antenna where it is. So means if my bottle is here, if I'm scanning this, Mahindra wants to know where my 4,000 engines are right now, where it is coming. So if one engine is there, another engine, so I can have a location within centimeters. So those time of real-time tracking with an automotive facility can be tremendous, and it can be harmonized with sensors. It cannot be done with only a single piece of an RFID, putting in that. It can be harmonized with so many other technology and can be fused with sensors and the partners like an IT partners like you and other people. So we are collaborating with different vendors so that we can give a solution with a collaborative approach to companies such like that. So we are pushing this right now. We have displayed one kit also, like
that if my like pallet is in right now in Gurgaon, if I move it, right now it's in Noida. So just an example to show that's okay in my geo map how it is going, how it is moving. So fleet management and all those aspects come into that picture. Yeah.
So that's a good one. One more question in this relation would be, like, okay, you are tracking the location, and after it gets to the final assembly where it's getting assembled, then you are also tracking that mother assembly that goes on, and then yeah.
If it allows to use that tag and antenna within that, the carrying the like a skid or the pallet which is carrying that part, so no, there is no doubt into that. If the concept is that if it allows, if the manufacturing allows, maybe sometimes you can put a tag, but we forgot to remove that tag or something. Maybe RFID in General Motors, which is there in India, which try to they have implemented first that let's say have an engine with a nut bolt kind of a tag, put it into the engine and ship it outside. So they are the company one who developed that. So why not that those sort of concepts? Now the tires has an RFID tags which embedded, which tells the cycle of the air pressures and all, which embedded with the mother serial card. So this is like variant tracking and digital tracking system.
Yeah, that's excellent. Coming over to Kalyan Ram, one thing that comes to my mind after looking at it, are you using anything based on physics models when it comes to the machine breakdown timing and those things? Are you using physics models, or are you using the empirical data that just comes from this and then try to make the historic and predictive on that?
Yeah, I think it's a very pertinent question. So what happens is getting physics model is a very big challenge because the machines are already there, right? I mean, not all machines are new. Some of them are not necessarily physics model, but at least you're getting CAD models these days for several machines. But physics model is a big challenge. So most of the time, waiting for a physics model or deriving a physics model is going to be a big task. And even then, even if you do for one machine, it's not sufficient because for each machine, each make, each model, things are very different. So the fastest way to get there is going to be empirical models. So what you can do is you can first start collecting the data, create an empirical model, go backwards, validate the model, empirical functions, and then start continuing from there onwards. So that, I think, in most cases is the most recommended practice in the current scenario, especially for large-scale implementations.
Okay. So one thing that when we see in a factory, the output that comes out is by the interaction of lot of players within it. One is the machines, which Mr. Kalyan Ram has covered. One is the material, of course, the flow of the material that has to happen. But there is one important thing, that is converting that material into the final good, either by the machine or by the human or by the joint working of human and machine together. So when it comes, we also see that the role being played by human. When I say human, then in the factory you have the line operators, you have the inspectors, you have people in the stores, and even when it goes to the bins and the trolleys and all, some human has to make it happen there physically. So there comes a human connectivity approach, and normally in industry, every human is given a task or assigned a task, and which we call SOP. Now, how many of you know what is SOP? So everybody knows. So it's a standard operating procedure. So now comes the question that the standard operating procedures are on paper. So has anybody heard of paperless SOPs, or is anybody using in your factories paperless SOPs? That's wonderful.
May I know from where? Pardon? PPF here. Anybody else using digital? Yeah.
Metalman.
Metalman. Perfect. Thank you. I mean, it's good to know that people are aware of digital SOPs. So did you find any benefit using digital SOPs to your factory? Well, I mean, I think you can. I want to. I know the benefit, but I mean, I would rather have audience participate and tell me that yes, did you find or not? What was your experience?
I am also from PPAP.
Yeah.
So first is First is of course it is paperless, and second is the suppose the manpower is new, so they don't know how to operate the machine. They don't know what SOP is suitable for this particular operation. So right now the particular SOP will be in front of the operator, either it is new or old. So he can see the particular SOP, because the same SOP will be in front of them, and they can operate the machine or equipment accordingly. So this is the main benefit to what we are getting.
Okay. Okay. Good. And are you also collecting data from that? Is the data getting collected? Means is the operator able to communicate back to the machine from the point of view of, let's say, an operator is doing a very quality specific job, and after doing the job, there is something which is called process quality. He has to confirm the process quality. So is that getting communicated to your servers?
Yeah. In some up to some extent we are doing this job, and we are collecting the data. The machine itself are getting this information, and some manual entries is also there, and we are collecting the whole data.
Okay. Okay. That's wonderful. So you developed the digital SOPs on your in-house? That is
up to some extent in-house, but we took help from external source also.
Okay. Okay. Good. So when we are connecting an industry, when we say industry 4.0, and when we say everything is connected, I think Kalyan, you would also like, and Lakshya, you would also like to share your experiences about digital SOPs, if in case you have.
Just quickly, I happen to see some of them. Definitely, like you said, new employees, it's a fantastic benefit. And more importantly, it's also establishing the process, methodology in a smooth way. That is something that I have seen in one of the customer places where we work.
So I'll simply say that asset identification, like we are the sensor manufacturer, somebody is a PLC manufacturer. So when a maintenance person have a PLC, he has to search a model number in Google, and then he find out the manual and sheet, the SOP of learning. Let's have a code on that, scan it, and have that SOP sheet out of that, and then operate it. So it's digital way to use it, and the digital things to read it. So way is an asset identification that we follows as a standards.
Fantastic.
That's a great example. That's a great example. So just my few cents to this is, one is of course understanding that a new operator can come and he can get himself trained very fast. One of the great utilization is that in India a lot of manufacturing is done by contract manufacturing methods. And what happens is, when you have a contract manufacturing, then every 6 months some new person is coming and he's going to do the thing. So what we lose is that the old person who was doing and who was learned exactly, who knew a lot of knowledge, his knowledge is lost, and the next person comes. He takes time to train, and between the time that he comes up to the speed, there is a quality loss. There is a loss of business, this thing, because he's learning. And but if the digital SOPs are in place, he can learn very quickly, and the supervisor doesn't have to run around for this thing. Secondly, digital SOPs can be made multilingual. That means an engineer can write it in English, but because the operator can only understand Hindi, so this becomes multilingual, and it gives you in both in real time. And then you can have SOPs with videos, with your lot of pictures and this and annotations and all, which makes it very easy, multilingual. Some of the systems are there that you can even do the barcode scan, and directly the operator who is working on that part, that scan data comes, so it gets traceable. So you get the traceability, and all these things are now available. So what I wanted to just quickly say, that we can also connect humans, and when we connect humans and machines, their maintenance and the material parts, everything together, we get the entirely a very developed and a very matured process. It initiates to that. Once the workers start communicating through the digital SOPs, supervisors don't have to run around to find what has gone wrong, which material has not come, what has not happened. He immediately knows in the real time to what actions to take. So you get data in real time. Then it's a transparent data. It's everybody knows the same data. It's in real time, and the decisions are taken very quickly because of this. I'm talking about tactical shop floor decisions that have to be taken. They get taken. So I think that's from my side.
Okay. Thank you, sir. Thank you so much for the enlightening session on digital SOPs and the smart manufacturing that we discussed today. I would now request Mr. Arindam Lahiri, sir, to please do the honors as a token of thanks to the industry experts. Purvi, can we have the tokens, please? Thank you, sir. So we have our next speaker on the board, Mr. Jitin Sahani. Mr. Sahani is the head of HRD and ER at Gurgaon plant of Hero MotoCorp. He got diverse academics in computer science engineering, MBA from IIM Lucknow and LLB from Law Faculty Delhi University. He has 22 years of experience in human resource for various industries across automotive, semiconductor and technology domain. He worked as a head of talent acquisition for companies like Broadcom and NXP Semiconductor. He was heading HR digital transformation for Hero and led HR BP vertical for various functions. He got keen interest in reading topics on world economics and HR transformations. Welcome, sir. Over to you. You have a presentation?
No, I don't have any presentation.
Okay,
that's fine. You can just
I'll just. Over to you, sir.
Thank you so much. Thank you, the organizing teams. And surprise, surprise, I'm not going to talk about technology. So, just about people, right? I have been given a very limited time. I know this is a Valentine week running, and we are sitting on Friday evening. So, will not consume much of time, but try to, just try to connect some of the brain waves. So some of the experience could be shared. And the session is about the skills, if I'm not wrong. So limiting myself to the context, I would not like to overarch things. When we talk of industry And because since morning people are talking about technical jargons, industry 4.0, 5.0, etc. If we see the evolution, the industry from the power of mechanics to electrical, to electronics, to technology, to whatnot, IoT of the world or whatnot, right? We are progressing so fast that even if we compare it with the Moore's law, probably the acceleration is much faster, right? And COVID made the world, it just not thrashed the world, but it also made this progression as a radical progression rather just a progression. It is an incremental progression. It is an exaggeration. So something which we were envisaging 10 years hence, it is happening now. But if we look back and we look at the best of our academia, and I'm talking in the context of India, are we moving with that pace? You may think about it. So what academia is focusing since the very beginning is on the fundamentals, the foundation, the conceptual knowledge, which is the right thing to do, right? But people, eventually the skillful people who are coming out from academia and getting a feed into the industry, they are the feed to the industry, right? Sir was talking about people. He beautifully explained, how important they are, not just technically, but also from their mental attitude readiness, how important they are in the industrial progression. So, is the academia also sensing, sniffing, and kind of, catching up the pace of progression of industry in India? Probably the answer is we're not sure. Or it may be a negate, right? And hence, most of the industries, they are dependent on consultants. And the brain feed of the consultants is the knowledge which they are gaining from the developed world. So if you see the whole eco cycle in India, we have a lot of intention today. We have a lot of excitement today. But is the ecosystem ready? I'll say it is getting ready. It is getting ready. Because it's been said that well begun is halfway done. I think we have begun it well. The intent is correct. And if we see this gap, if I say that the curve of progression of industry is this and academia is this, there is a void, which has been created, but then this void is getting filled with a very skillful intention in the shape of organizations like ASDC, in the shape of organizations like National Skill Development Centers. Because they are giving the feed to the industry with their curriculum, which is more vocational oriented, not just conceptual oriented. It has concepts also, but it is more eyeing towards what industry is doing. They are sniffing every day what industry is doing. One of the ILO report, International Labour Organization, they mentioned that while there's a lot of young population in India, but the crude fact is the engineers, the number of engineers who are getting ready for the employment, just 3% of them are employable. Just reflect it. Just 3%. It's not that they don't have potential to be employed. They don't have potential to grow to the extent of their batchmates from the counter countries. But the problem is the attention is more towards just conceptual knowledge. And hence, I think the beginning here today, what ASDC is doing as a collab with IIT Delhi and creating a curriculum, which can be more application centric, this is the first, but a very strong step. Very strong step. And let us have a round of applause for that. I have a first-hand experience, of the value this institute has added to Hero MotoCorp. Earlier, when, Sir talked about the lines, when we were sourcing people for the lines. Most of the time, we were dependent highly on contractors. There was a lot of variation in the quality and the attitude and the behavior of people. Their mindset was very different. We created a Gurukul as a collab with ASDC at our premises, where people are getting skilled as per not just conceptual knowledge, but also the practical course curriculum which we are needing in industry, in the automotive industry. And it resulted in such a beautiful outcome that after 3 years, I'm so excited to tell you that all these people are not only employable, but they are extremely, extremely cost valued for our organization. And we have given a journey to so many lives, which is, I think that's an everlasting value. Now, I would, as it's about sharing the brain waves, would like to tell you some of the emerging practices which are very valuable in the same spirit what ASDC or IIT Delhi is trying to, or the other respectful organizing teams they are trying to do here. There's an emerging concept of professor of practice. Have you heard about that? So many, because government of India is kind enough, with the right intent, they are making many universities in India, and they are giving them all the autonomous rights and power to decide on their course curriculum, right? So now these universities, they are coming up with the concept of professor of practice. Now, this professor of practice is somebody who has spent a long journey, a very valuable journey in the industry. They know the industry, they know the application science. They are joining the academia, and they're sharing the whole crux of their life in that academia. And telling academia what should be the right course curriculum material, what should be the right subjects we should be introducing, so not only concepts, not only fundamental, but the applicability can also get strengthened, which can eventually make people more employable from the very first day. Not only that, there is a reverse flow which is happening. Many of the great academics with a very futuristic approach, they are deploying their professors to the organizations, to the corporates, to the industries. They're telling them to spend 2 years as an employee. So when these professors are going there, doing the work, they get to understand what are the practical challenges. What B.L. Thareja tells and what happens when the rubber hits the road. They know the difference now. Okay? So when they come back, they advocate and they promote why it is logical, why it is reasonable to bring in an application, a skill-driven subject along with the theory. I'm not saying the theory is very important. I'm not demeaning theory by any means. It is all about thinking something which I'll call as less is more. Okay? You have limited time. Like, today we are stretched. We have taken a lot of time. I'm sorry, I'm also taking a lot of time, but guarantee you won't take more than 3-4 minutes. So in the limited time, you need to fit in everything. If there is an engineering program for 4 years, you have 4 years only. You have few hours only, right? So you need to figure out what is important, what is relevant in current context, and what is not relevant. It is more important to figure out what is not relevant than to figure out what is relevant. And chuck out what is not relevant and add on what is more relevant, right? Everybody is talking about manufacturing today, but what will happen after 10 years? Probably we will be like another Japan. And what is happening in Japan? There is a manufacturing saturation. What are they focusing on? The power to spend has increased multifold. Everybody has so many gadgets. 20 years back, I was not having an AC at my home. Today, I have 6 ACs, right? But when it comes on after-sale service of that AC, I'm always iffy because of 2 things. If I call up Mitsubishi guy, sorry, I think Mitsubishi was also there somewhere. So let me not take Mitsubishi. If I call up, say, Samsung, to set something right. So there are 2 things which are happening. In my mind, I know that, this is going to cost me a bomb, right? Second, I may need to wait a long for the availability of the parts. Whereas in a developed skill ecosystem, I don't need to rely on a limited set of opportunities. The service sector will boom, right? The after-sale service will boom. Because if you have skillful people available who will provide you a standardized service, which is not happening today. अभी क्या होता है? When you call up somebody from the secondary market, वो कहता है सर उस्ताद ने सिखाया था, that's what I know and that is what I'm doing, right? They don't have any formal skillful information and education. So you are again iffy. As a consumer, you are again iffy. And this is going to happen after 10 years. This skill development centers are going to give you that trust that there is a secondary line of network which is getting ready other than OEMs, which will offer you a trustful service at a reasonable price. That is the next wave of revolution we are sitting on, and we should start thinking right away. So with this, I will pause, and thank you so much for the patience listening. Would be happy if there is any question I can address.
The skills again are spread across multiple aspects, especially in your kind of industry. So what is the kind of scale and size you're able to kind of derive out of this? I know it will evolve, but at the current levels.
So at the current level, if I talk about, I'll call it a pilot first of all. We have a size of 120 technicians who are getting trained at our Gurukul through ASJC. However, we have a much broader opportunity where thousands and thousands of technicians are getting in through contractual network, right? And I'm sure once, because now we are a tenured organization, there is an immense opportunity for an organization which is very new. We are setting up the base because you can correct the things from very beginning. Sir was talking about a fixed term engagement where every 7 months you need to keep floating, your employee, your technicians, because of the fact that otherwise there will be an establishment, right? And many liabilities. I will not get into that direction, but yes, to answer your question, our pilot is very successful, and we are going to make it big. Okay. So with this, I conclude, and thank you so much for the patient listening. You are a wonderful audience. You have a question? Sorry, there's a question.
See, you have all the plants and everywhere. So the workers, the operators, machine operators.
Right.
The age could be 40 to 50 range or something. How do you really train them for these technologies? Because that's a big gap. In Japan, I could see that the people get trained a lot on all these type of technologies, even though they are not engineers or they are not even diploma holders or something.
Right, right.
I think there is a gap in India, and the people are scared about picking up this technology. Youngsters, of course, for the gadgets and pads and everything, they can pick up very well. But there is a big gap that we are finding. So how Hero MotoCorp is working on that?
Right. See, we have a mixed segment of workers. Okay. One, you said that there are tenured workers. Of course, there are workers who are not tenured, but they are young, and they are coming through a fixed term engagement, right? The only downside is that we need to, after 7-8 months, we need to tell them to, go, right? They are skillful. Even people who are at the age of, say, what you mentioned, they are also skillful. Why they are skillful? Because, what is a skill? Skill is a mix of technology, attitude, and experiential journey. Now, these people, they, with the change in technology, they are getting trained every time. The only difference is, for that training, what we are doing, we are calling external. Suppose, I think automotive industry has seen a huge disruption. From BS4 jumping to BS6, then OD1 to OD2 and whatnot. Today we are talking about the hybrid fuel, whatnot. So, whenever we do such kind of transition, again, what I said in the beginning, what we do, we are mostly relying on the consultants. We bring in consultants, we get our people, trained, we create we have a mature ecosystem where we train the trainers. Then these trainers, keep training the people. So this is a need-based approach. What I'm hinting here is a proactive approach. With a holistic ecosystem, with a 360-degree thought process, with a planned ecosystem, there could be a consistent supply of a skilled workforce. Otherwise, it will be a fluke. एक छोटी सी स्टोरी सुना सकता हूँ? Okay. So what happened, and this somebody told me a few days back. So there was a king who was fond of hunting. He went to jungle with his soldier. He saw that, there are archery marks on all the trees. वो जो गोले होते हैं, red, green, blue. And there's an arrow at the bullseye in the middle. Okay, 10 pointer, 10 out of 10. Everywhere, on all trees. And this guy was surprised. He was dazzled. He said, who is this person and what a skillful person is he? So he told his soldiers, bring that guy, here. I would like to reward this person. So there was a 16-year-old boy came in. Sir, I have done this. So then the king rewarded this guy and he said, how you did it? Because none of my soldiers is so skillful. He said, nothing. I just played the bow, right? Wherever bow hit, I made a painting around it. So that is the difference between a planned and a strategic approach versus a fluke. Abhi jo technology change ke saath mein what we are doing, that's a knee-jerk approach. But with an ecosystem, what we are trying to do, that is the plan and a strategy thing. With this, I conclude. Thank you so much. You are a lovely audience.
Thank you, sir. So I will quickly request Mr. Anup Vadva to take the stage now. A brief introduction about Mr. Vadva. He is an engineering alumnus of IIT Delhi and a certified professional in technology management from IIM Ahmedabad. His passion for digital electronics started in college and later took him to an exciting career in the field of industrial automation and technology management. Mr. Vadva has served in the systems engineering and social projects for BHEL, a premier public sector company, Rockwell Automation, a leading technology MNC, and Samtel. As a director in AIA, he conceptualized and steered the industry partnership with IIT Delhi and Department of Heavy Industry to set up the IITD-AIA Foundation for Smart Manufacturing. Over to you, Anup sir. The stage is yours.
It was truly wonderful to have a breath of fresh air through your talk, sir. I'm a firm believer that technology is just a tool in the hands of people, and the focus on the revolution or evolution has to be on people. So this session is about skilling, it's about people, and it's also about taking responsibility between academia and the industry. Fortunately, we've been able to create a model where we don't say academia and industry. Our foundation is kind of a holistic. Whoever works for the foundation has got these twin antennas always ready, which is that we are here for a purpose to fill the gap. There is a talent pool, there is a talent shortage, and then there is a opportunity for the country to leapfrog in manufacturing. And as long as we can see that triad, we can see the vision, we have a game plan ready. The challenge now is for us and ASDC, with whom we are going to shortly announce a partnership, is to prepare the young minds. And like my predecessor said, are the colleges ready? I don't think they are ready because they don't understand the complexity. They all assume that, if they learn a course or two, they can manage without much of difficulty. But we've seen through the years that this revolution will require people who have not only a course or two under their belt, they have to be able to think in terms of multidisciplinary approach to a problem. They got to be able to look at the cyber world and the physical world with equal ease. And that's not something which we see even on the shop floors. We have an IT department, and the IT department only works on data, and we have an OT department which works on the machines. what we want to do is to be able to achieve smart plants like this where the machines can talk. Why do we need to figure out what's wrong with the machine? The machine is capable of telling us what it needs, and it's for us to set the other systems, the non-automated systems, as my friend Sandeep said, to be able to respond in that kind of a time. The other thing which we also need to recognize, that this talent cannot be working only for the top-end companies, including the Marutis and Hero MotoCorps. They have a very sound management. We have no doubt about their future leadership. But it's the next level base, the mass of Indian manufacturing, the MSMEs, which account for more than 3/4 of the employment, more than 50% of the turnover. They are at risk of obsolescence. And this is not what I say, this is what the World Economic Forum said way back in 2018, when the Indian government took this problem and this challenge seriously. So to be able to cross over from industry 2 to 3 to 4 is complex. As I said, it calls for a multidisciplinary approach. And therefore, we have to have those partnerships where the boundaries are blurred. And to be able to think like that, to be able to, also have an India-specific strategy where we are clear what are the benefits of automation versus what are the benefits of digitalization. We are trying to club these technologies, but we ought to recognize that automation will increase the throughput with less people. But the moment we digitalize and we make information available to people on their mobiles, then they have to individually also feel empowered. So one is not got to be treated exactly the way as the other. And now we have to say that they have to work together. To be able to conceive this, to be able to deliver on the ground, we have a flagship initiative of the government. There are many companies, there are many organizations which are working, but sadly, we are not under the same banner. We are working for ourselves, we've got to work for India. And that's something where I think we ourselves will get challenged, whether we can break through the boundaries of different organizations and work together. We have a curriculum in place which Professor Jha has ably led so far. The challenge is for us now to train many more faculty and then take it forward. Just having a curriculum and having the connect with industry or having a connect with colleges is not enough. We got to inspire those faculty. How are we going to inspire? Do they actually go to a plant like Maruti and Hero Motors and get excited? Perhaps not. How are we going to bring that excitement to the door by which they would like to come and participate in such seminars and understand the challenge? So I think there are many, many questions which we hopefully will address with brilliant minds as we have in the audience today. All I can say is that our association brings in more than 2/3 of the use cases. So I think it's a good nucleus to start with. We can then expand and develop further. My last slide is about capable people. Capable people will produce capable industry, and capable industry will produce a capable nation. So this is where we have to reach. That's the big game plan. And I'm very happy that we've come very, very fast in our association with ASTC. I think in less than a month, we had a top level alignment followed up by an excellent, energetic team from Mr. Lahiri's team, Garima and her other colleagues. So I would now like to pass on the baton to Mr. Lahiri to come and say what his vision is for building this gap. And all I can say is that we are there to support you. Thank you so much. Please, sir.
Okay. Okay. I think it's there. No, it's okay. Yeah, sure. Yeah. Human smartness still is there, other than the machines. Very good evening to all of you. It's been wonderful, absorbing throughout the day the various elements of technology, and also see a lot of different use cases, so which obviously makes you feel that much more connected in terms of what you want to do. We are an organization which is largely focused on human resources, skilling human resources, skilling, reskilling, upskilling of human resources. This is the reason why we exist. We've been around for about 13 years now, and the structure is that it is one of the first sector skill councils with the National Skill Development Corporation, NSDC, which was set up in 2009, and we came into being in 2011. We are also an accredited awarding body affiliated by the central regulator, which is the National Council for Vocational Education and Training. We have basically 6 key stakeholders for our organization. 3 industry associations, ACMA, the Component Manufacturer Association, SIAM, the Vehicle Manufacturer Association, and FADA, which is the Dealers Association. And we get support from 3 ministries, Ministry of Heavy Industry, Ministry of Skill Development and Entrepreneurship, and Ministry of Road Transport and Highways. This is the vision and the mission for ASTC, and we effectively are focused on automotive skills. How do we add higher value to that process? Making skills aspirational. Skill development or vocational education in this country has always taken a backseat. It has never been aspirational. Somebody going to ITI was always considered that he did not have any other choice in life, and therefore he is ended up being at ITI. And I think for the country to make progress in manufacturing as well as service segments in and agriculture, I would say, in terms of having the right level of productivity and quality, skills is a mandatory part of it, and skills has to find its place of importance in our daily lives. We also are very engaged in honoring and celebrating skills, because that's when we make it very effective. This is what we do as an organization. We set up the standards, we set up the qualification standards for human resources. We currently have about 140 different job roles for which we have course curriculum content, which spreads across the entire automotive value chain, right from engineering, R&D to manufacturing to sales, service, and driving. Everything that is related to automobiles. We do coordinate with the training of trainers, affiliation of training partners. We do the assessment, certification, placement. We organize skill competitions both at the national level and also represent India at the Global Olympics of Skills, which is called World Skills. Again, just to give you a small anecdote about what we have done to skills, is that World Skills is like the Olympics of Skills. It is organized every 2 years, and more than 100 countries participate in this. India first participated in World Skills only in 2011. So as a country, we didn't know that World Skills existed. Okay, so that's where actually our skills journey has started. And we of course do end-to-end projects for implementation of CSR and other special projects. This is our governing council. All are nominated by these various associations and the ministry. In terms of the training system, we offer short-term training programs which are between 200 to 600 hours. We have even micro-credentials which are 30 hours or even less than 30 hours. The minimum that we have is about 7.5 hour training session. We do upskilling program through a government program called Recognition of Prior Learning, which is reskilling of existing workforce from 12 to 60 hours. And of course, we also help the government administer the apprenticeship program for the automotive sector with courses between 6 months to 36 months. We collaborate with a lot of OEMs. Just to give you some examples, Eicher Motors and Toyota, we have some very interesting courses which are available on our website, available free of cost. Almost about 100,000 people across the years, last couple of years, have taken advantage of these programs and access this knowledge. So that fulfills our objective in terms of having awareness spread on automotive skill area. We've partnered with Bolt Earth, which is one of the charging station producing company, and we have that program. We also have a partnership with Google for digital marketing program, which is again available free of cost on our website. Then there are certain more paid programs that we have with a few other partners. Let me come straight now to the program that we've co-designed with FSM, IIT Delhi, AIA-FSM, in terms of offering program for engineering graduates in college in the field of smart manufacturing. The idea is to build a pipeline of fresh talent with the right competencies which can get into OEMs, not only OEMs, but more importantly the Tier 1 and the Tier 2 suppliers in the supply chain to implement smart manufacturing solutions. All that we have listened to since the morning cannot happen eventually only with the machines and the parts and the software. You need people to be able to manage them. And if you don't have those people and the brighter people, the more interested people coming into this space, you will not have enough growth in that segment itself. And we will also ensure that these programs are credit aligned under the National Credit Framework Policy and are also aligned to the National Skill Qualification Framework so that the students get the academic benefit of doing certain programs and they don't have to do it as an additional burden or an additional effort in terms of their program. The program is to formally develop a curriculum framework, and we will have it approved through the National Council for Vocational Education and Training, NCVT. The students will offer this, or will take up this course suggested in the 5th or in the 6th semester for the basic and the advanced level of the program, which is essentially priming them for doing the hands-on work. And then on the 7th semester, we're planning to get them to do a project here at FSM in terms of a hands-on project before the final semester in which they can actually go to the industry and do an internship program. So the journey is that start to get the foundation, learn a little more about it, start doing something on those what you have learned physically, and then go and start looking at applications in the real world scenario in the industry. And that is where we see that the manpower will be ready for deployment into the industry. So the benefit for the students obviously is that they get a curriculum which is skill based, which is industry aligned. It's credit notified. They will have practical knowledge at IIFSM with 70% of the time they're spending on practicals and regrouping and learning the theory. Internship with the automotive industry to implement the smart manufacturing, both at the OEM level and also more importantly at a Tier 1 and a Tier 2 levels. And then eventually that opens the pathway or the gateway into the formal placement of these individuals into smart manufacturing and organization. We're looking for support from industry in terms of suggestion and feedback for the curriculum. We need validation letters for approval to be submitted to the government that yes, this program is something which the industry feels is a right program. Internship opportunity to the students so that they can actually practice it in the real world environment and get exposure to it before they actually can be placed with these organizations or similar other organizations. So I'll stop here. I think it has been a long day, but we'll stop here at this point in time. Thank you. Thank you very much.
Okay. Thank you so much, sir. And now I would like to call upon the stage Dr. Sunil Jha, sir, Mr. Anup Wadhwa, sir, Mr. Sunil Mehta, sir, Mr. Arindam Lehri, and Mr. Jitin Sahani for the MOU exchange between ASDC and FSM. Please be on the stage, sir. Garima, please help us with the MOUs. I would now request Mr. Sunil Mehta, sir, to please honor the industry experts, Mr. Wadhwa, sir, Mr. Neeraj Sahni, Jitin Sahni, and Mr. Arindam Lehri, sir, with the token of thanks. Urvi? Yeah. Urvi, can we have them? So, before we move on to the tea breaks or the high tea, I would request Mr. Vaibhav Anand and Mr. Atul Tahiliani to give a quick demonstration of the FSM facilities. Over to you, Atul. हाँ, switch कर दो. निकाल लो. Is it audio?
Yes, there will be.
Let's start with what?
This.
If it's in there.
Order placement. But how will you place order?
Concentrate. Just concentrate.
मैंने मैसेज कर दिया उसे कि बी रेडी.
चलिए एक बार ये चेक कर लेता हूँ साउंड.
हाँ तो क्या?
क्या गया?
You will place order for what?
क्यों चेंज कर रहे हो सर?
करना क्या चाहते हो आप?
साउंड.
साउंड तो इसने बंद कर रखी थी ना. तूने बंद तो कर रखी थी साउंड.
फुल आ भी रही है. अब तो इट इज देयर.
Okay sir, it's okay. I'll think.
I'll explain whatever is there. No issues. You will explain some. I will explain some.
साउंड आ नहीं रही है.
कोई बात नहीं.
फिर just give me a demo ना. यार वाले समझा दूँगा तो बाकी समझा.
Okay. Welcome everyone. My name is Atul. Just short session to show you the different projects of FSM IIT Delhi. We had a planned live demonstration, but since that is slightly not possible due to logistical and time constraints, we will be having this particular live demonstration virtually, right? So couple of things that we are able to show will be through live stream of cameras. The things that are not being able to be captured on the live stream, we will show through videos. So our demonstration sequence starts with this combination of AMR, which is a autonomous mobile robot, combined with a cobot, which helps in human-machine collaboration. And as you can see, the cobot is equipped with a camera, which is able to accurately detect a human-placed pallet, and it is able to then pick up the same and insert it into the first workstation. This is what we are able to see. On the right side, you're able to see the application and what the feed of the camera is in real time, how it is detecting the marker on the pallet. So it does this particular localization twice. Once when it goes to pick up the pallet, and second when it is going to place. So there are two markers, because the docking of the AMR is also not accurate to the MM. Hence the cobot needs to collaborate every single time. So here you can see it is trying to find the marker of the first workstation, and it will then hence recalibrate and then place the pallet in the first workstation. Let's go proceed to the live demonstration of the 3-workstation assembly line. So we have this particular 3-station assembly line. In this 3-station, we are having palletized assembly operations with the entire sequence divided into 3 workstations, right? We have built these workstations deliberately with heterogeneous hardware to show machine-to-machine communication across different types of automation companies' software and hardware, right? So first workstation is built on Allen Bradley and Rockwell suite of hardware. Second is BNR automation, and third is based on Mitsubishi. All of them have the IoT protocols like OPC UA enabled in them, and we are having data coming to our production server. We have used this functionality to create this IoT order placement app, and we are able to, in real time with the right authentication, place an app to our production server, which is then being pushing a command to our PLC. So anybody can volunteer if you want to place a order, maybe blue, red. Fine, I will proceed with red, okay? So the portal tells me order has been placed. I will go to the real-time dashboard of the workstation, and here you can see that the machine has been given the command to place an order with the red part. And soon we will be able to see in the live stream itself that the execution for the live red part will begin shortly. We can see the same also in the live stream over here. So as we can see, the network is a little bit of an issue. So the live stream is an issue, but the order actually has started, and that the same machine tags are being visualized onto the dashboard. As the sequence proceeds, we are also having a track and trace through the 3 workstations. Hence, we are able to see the percentage completion in real time. And we are also benchmarking the process through live OEE calculation, which is overall equipment effectiveness. Okay, so here you can see that the first workstation scans the part, all 4 faces of the part, and it is able to quantify the quality of the part if it is matching the 2D profile that is already, the camera has already been trained on. And once the quality check is passed, then it proceeds to the next order. So this is how we have our 3 workstations. I will proceed to the next project, which is a multi-process robotic cell. So the 3 workstations represent a linear fashion in which the operations are happening one by one. If a company, if a manufacturing industry has to respond to dynamic orders, dynamic changes in their orders, right? New parts, new customizations, then we are able to demonstrate the capability through a flexible manufacturing cell with a 6 degree of freedom robot being a facilitator. So we have designed the same assembly process that was happening in the 3 workstations, happening across this cell, with arranging workstations around this 6 degree of freedom robot. Along with the functions that the 3 workstations were able to perform, we have also included pneumatic testing as well as packaging. So this is an all-in-one cell that is able to do the inventory to the packaging process, all of them inside one cell. This is being achieved because the 6 degree of freedom robot is attached with a master-slave end effector, which is pneumatically attached to each other. The slaves actually are on the different corners of the cells, and they have the various tools that the robot can use to perform the various operations. So we have a QR code scanner to scan the inventory, and further we are having a pneumatic gripper and a pneumatic screwdriver to perform the assembly operations. And we are also having this pneumatic suction cups to handle the packaging part of the sequence. The interesting part about this cell is that we have not used a traditional way of programming the robot through the teach pendant. We have actually used KUKA libraries with a Siemens PLC, and we are able to coordinate the entire sequence of the cell using the PLC programming of the Siemens PLC. So this shows that this exhibits a further, I would say, further way of interfacing robotics and automation, and this also ensures that we can reuse our same PLC compliant workforce to implement robotics, which should be one less hurdle to implement robotics in manufacturing. So this is how the complete work cell functions, right? Moving on, we will have some augmented reality real-time demos. I hand over the dais to
So I'll start with video, I'll start with this.
Yeah, I'll start with
I'll start with this, yeah. So I have some image targets with me, and I'll try and show some real-time demos with you also. That we go here, and you're able to see the screen. Okay. So this is one application that we created. have the login option that you have to log in from user ID. The idea is that since now you're not able to go to the lab and see all the kits, I can bring the kits to you. So starting with that, let's go with the R1 kit, and let's go for the hardware introduction for the controller kit. Okay. So this is the image target that I'm going to use, and as soon as the camera recognizes the image target, it will trigger the experience. So you can see the kit in front of you. And the good thing is it's not just an image, it's a full 3D model of the kit. So you can go in as close as you want or as far behind. And if you want to know about any of the part, all you have to do is click on the part. It will give you that information. A good thing in AR, normally what we see is it's a one-way communication. But in this scenario, what we have done, every click you do is also being tracked. So for example, if you ask 100 of employees to get trained on something, you can actually track if they're doing it or not. So it's a good traceability option also. I'll show one more thing in this. So we can also go for an exploded view of the mechanism kit. Let's go for that. So you get the full mechanism kit in front of you. And if you want to add any kind of animation sequence, you can actually do it. I'll click on the explode button. It will start the simple explode animation in any CAD video. And you can actually visualize how the parts look like. The important thing is that you have to make sure the image target is always visible. So this is one sequence. I'll just go with another one very quickly. Can I get that image target? It's a good application. I'll show how you can better explain working of a cobot or a robot. So as in front of me, I have the robot. I have to see this target, or I can go for another target also. And have that robot in front of you. I can scale it up, I can scale it down. And the good thing is, if I want to know how an axis is going to move, all I have to do is select the axis and just move it. In real time, you're able to visualize how each axis is going to work. It's a better application as a learning tool, as well as a very good marketing tool or a buying tool also, buying guidance tool. And before buying something, you actually try it out in real time. So that is that. Rest we can show by the video, I think. Just so the application can show the video. I'll explain. Which one would you like? HoloLens. HoloLens 2, yeah. Super. HoloLens 2, yeah. So this is one expert maintenance system that we created. The idea is that whenever there's any kind of issue with the machine, the user or whoever is on the site will get a WhatsApp message implying that the issue is there. So there is no latency between the error happening and you knowing about it. The second part of the system is that even if the expert engineer who is supposed to rectify the error is not on site, you can actually use a HoloLens and then it will guide you. So you can have a decision tree kind of a situation in which the HoloLens itself will try to find the root cause of the error, and after it is identified, it will tell you how to rectify it. For example, right now it's asking if workstation 2 is also getting pressure. So if both the workstations are not getting pressure, that means the issue should be in the main line somewhere. So it is guiding you with photos and instructions. And if we say the workstation 2 is getting pressure and 3 is also getting pressure, that means there is some issue inside workstation 1. Then it will guide us how to resolve that. So in case of critical situations, you can use this device because it's even if the engineer is not on site, you can get better instructions by this. And it's always better than a video. So now it is asking you to go behind the machine. So it's a full 3D environment. It doesn't have to be a 2D image like that. It can be a full CAD model of the machine. And now it is asking you to perform the steps. So it can give you the exact direction to move the dial into and also a photograph there. So you know what to do. So this is one application. I'll go with this new one. Okay. Okay. So this is kind of a mix of a lot of technologies. It's with the HoloLens, it's mixed reality, it's IIoT, and it's robotics also. So we did this application to see how we can actually control a cobot with just the AR, or a mixed reality, I would say. So this can have bigger applications in the future also, but right now we are able to actually control each and every axis if we want. So without being on the site also, you're able to control such things. So that is in this application. So I hope you get the idea. I'll move to the next one. Okay. So this one is again a full maintenance sequence, how you're able to visualize in front of you each and every step, and you can actually mark So sometimes in a machine, when you're repairing something, there are a few areas which you are not able to or should not touch or interfere with. So with this kind of application, you're able to highlight exactly which point to touch or which not to touch. So you're able to see what all screws to unscrew and everything. And you can add information like what screw size to use, what tools you should have, and every other information you need. And before actually doing it on the real machine, you're able to visualize side by side. Or even if you want, you can superimpose on the actual machine and get instructions real time. So you get the gist. It's going to just show the sequence of, yeah. Let's see which one is that. I don't think it's there. So I think these are all the videos we can show right now without going to the real lab. We can close. Yeah. So we can close with this.
Thank you very much.
Thank you. Aman sir. Yeah, please. Which it depends actually on the number of steps you want to get it performed. Like for example, the sequence for this exact sequence was prepared by an intern actually, and it was done as a 6 months project, and in which they were able to come here, learn how to work with a new device, a HoloLens, how to work on it, how to prepare applications and do it. So it doesn't take long for a beginner also. For a professional person, it will take even half of that. So normally it is advisable to do these things for very critical situations and high probability errors. So that is going to be the biggest ROI, I would say.
The prerequisite being that we have a detailed CAD model of your equipment.
And the steps to follow, obviously. So. Yeah, so we are using Unity as a platform in this. Yeah. So it gives a lot of control over a lot of other features, so that's there. Any other queries? Thank you. Thanks a lot.
I would now request Mr. Anup Wadhwa sir to please hand over the mementos. Atul and Vaibhav, please be on the stage. So in light of all the hard work you have done with the support of manager FSM, this is for your contribution.
एक नमन के लिए भी चाहिए हमें। नहीं ले आता हूँ सर। चल सर।
I'll bring that one.
Thank you, sir, and thank you, audience. So with this demonstration, we hereby mark the closure of this event. We have the high tea waiting for you at the first floor. Please enjoy the drinks. Thank you.